Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
On a cool evening in early October, the JWST sent ripples through the global scientific community by detecting a mysterious signal originating from the Andromeda Galaxy, the closest major galaxy to our own Milky Way. For decades, humanity has gazed at the stars, searching for signs of extraterrestrial life or phenomena that defy natural explanations. While we've uncovered countless cosmic wonders, new stars, planets, black holes, and even promising hints of habitable worlds, the discovery of this alarming signal from Andromeda marks a significant turning point in our comprehension of the cosmos. Before we delve deeper, don't forget to like and subscribe for more exclusive updates. Michio Kaku. As soon as the signal was detected, global attention shifted to Michio Kaku, the esteemed theoretical physicist and futurist renowned for his work on string theory and his enthusiastic support for space exploration. Kaku has long argued that the quest to find extraterrestrial life isn't merely a scientific endeavor, but a fundamental question about what it means to be human. Are we truly alone in the universe? The reception of this enigmatic signal from Andromeda might finally start to answer that profound question. The James Webb Space Telescope, a marvel of modern technology, was designed for multiple purposes: to peer deep into the universe's past by observing the earliest light from galaxies formed billions of years ago, to search for exoplanets, and to provide detailed information about the atmospheres of these distant worlds. However, no one anticipated that it would become a beacon for potentially intelligent signals from a neighboring galaxy. Located approximately 2.5 million light-years from Earth, the Andromeda Galaxy is a familiar celestial neighbor, often considered a twin to the Milky Way. Despite this proximity, the vast expanse between our galaxies has made astronomers cautious about expecting any clear signs of intelligent life beyond our own. When the JWST detected the signal, its characteristics immediately raised eyebrows. It wasn't merely electromagnetic radiation from natural stellar sources like pulsars or black holes, which are known to emit repetitive signals. Instead, the frequency and structure of the Andromeda signal suggested something far more intentional. The patterns were too orderly to dismiss as random cosmic noise. To add to the intrigue, the signal repeated at intervals that resembled structured, coded communications. This could potentially indicate the presence of intelligent life capable of creating and transmitting signals across immense cosmic distances. In his public addresses, Kaku explored the possible ramifications of such a signal. Firstly, he emphasized the monumental scientific significance of its detection. If the signal indeed originates from an advanced civilization in Andromeda, it would represent a historic moment for humanity. For centuries, we've looked up at the sky, wondering if we are the sole intelligent species in the cosmos. Discovering evidence of intelligent life in another galaxy would suggest that life isn't a rare occurrence, but perhaps a likely outcome of the universe's natural processes. The Drake equation, long used to estimate the number of intelligent civilizations in our galaxy, might require serious reevaluation. The signal from Andromeda could imply that the universe is teeming with life in ways we hadn't previously imagined. Implications. The implications extend far beyond science and astronomy. They touch on philosophy, sociology, and even theology. For Kaku, the philosophical dimension is unavoidable. Humanity has long operated under the assumption that Earth is unique, and by extension, that we hold a special place in the cosmos. Detecting an intelligent signal from Andromeda challenges this deeply ingrained belief. It raises profound questions about our species' future. Are we on the path to making contact with another civilization? If so, what could that mean for our cultural, technological, and social development? Might we be considered a primitive civilization in comparison? More unsettling is the possibility that the signal comes from a civilization with technology far surpassing our own. Kaku also pointed out that while the signal is thrilling, it carries potential risks. He referred to the well-known concept in the search for extraterrestrial intelligence called the dark forest theory. This theory posits that intelligent civilizations might choose to remain silent to avoid attracting the attention of more advanced, possibly hostile species. If the Andromeda signal is a deliberate message, it could be a plea for help, a declaration of existence, or, more ominously, a warning. If we're receiving their communication, it suggests they either don't subscribe to the dark forest theory or are unaware of its potential dangers. This brings us to an immediate concern. What should humanity do next? Should we respond? Kaku has been an outspoken advocate for caution. Reaching out to a civilization millions of light years away isn't without significant risks. Even if the signal is benign, any reply we send would take millions of years to reach Andromeda. By the time our message arrives, the senders might have evolved beyond recognition or ceased to exist. The vast timescales involved create a paradox where entire civilizations could rise and fall on both sides before any meaningful exchange occurs. The technological achievement of detecting such a signal is itself extraordinary. The JWST wasn't specifically designed to search for extraterrestrial communications, making this discovery even more remarkable. It raises questions about how many other signals we might have missed from more distant galaxies. What if other signals have gone undetected because of our technological limitations? Kaku often stresses the importance of investing in more advanced space observation technologies. While our current tools are impressive, they are just the beginning. To fully comprehend the universe and potentially communicate with distant civilizations, we'll need even more sophisticated telescopes and observational arrays. This discovery could accelerate developments in this direction, prompting space agencies like NASA and private enterprises to expedite their plans for new space-based instruments. However, the detection of this signal also brings up concerns about how the international community will manage such a monumental finding. Until now, space exploration has been largely collaborative, with nations working together to expand our collective knowledge. The prospect of contacting another civilization might, however, introduce a new level of competition. Countries might rush to be the first to decode the signal, claim the prestige of first contact, or leverage the event to assert dominance in space exploration. Kaku cautioned that humanity must avoid repeating past mistakes. History is filled with examples where competition and distrust between nations have led to conflict. He advocates for a unified, collective approach, emphasizing that this discovery belongs to all of humanity, not any single nation or organization. The true nature of the signal remains unclear, and deciphering it will likely take years or even decades of meticulous analysis. There's still the possibility that it could be a natural phenomenon we do not yet understand. Kaku and other scientists remain open to all possibilities, advising against hasty conclusions. However, if this signal is indeed from an intelligent civilization, it could serve as an invaluable learning opportunity. Even if we can't decode the exact message, understanding its structure might provide insights into how other intelligent species communicate. It could introduce us to entirely new concepts in mathematics, language, and science that we haven't even conceived of yet. Moreover, the signal might be a form of communication so advanced that our current knowledge can't fully grasp it. Just as ancient civilizations couldn't detect radio waves because they lacked the necessary technology, the Andromeda signal might be part of a broader, more sophisticated system that exceeds our current capabilities. This possibility fascinates Kaku, suggesting that our civilization is still in its infancy on the cosmic scale. We might be like children overhearing a complex conversation, able to pick out certain words but missing the full context. The future of humanity could depend on developing the tools and intelligence needed to engage with these advanced forms of communication. The journey ahead. One of the most exciting possibilities Kaku raises is that this signal might not be unique. He theorizes that other signals could be hidden within the cosmic background noise, awaiting discovery. Given the vastness of the universe, it's highly unlikely that Andromeda is the only galaxy harboring intelligent life. If one civilization can send a signal, others might have already done so. The detection of the Andromeda signal could be the first in a series of discoveries that radically reshape our understanding of the universe and our place within it. The prospect of receiving a signal from an intelligent species in Andromeda opens a new chapter in human exploration. While the challenges are immense, the potential rewards are equally significant. Kaku's enthusiasm is infectious, but his call for caution is well-founded. The path ahead requires careful thought, balancing ambition with prudence, and maintaining an openness to whatever truth the cosmos may reveal. Whether this signal leads to first contact or simply enhances our understanding of the universe, It marks a pivotal moment in scientific history. It's a moment that will be remembered for generations, igniting the imaginations of dreamers, explorers, and scientists alike. As we stand on the brink of one of humanity's greatest discoveries, private companies and space agencies worldwide might feel inspired or compelled to accelerate their plans. Enterprises like SpaceX, Blue Origin, and others could seize this opportunity to advance their space initiatives, possibly pushing for the development of more sensitive instruments capable of detecting signals from even greater distances. The ultimate aim would be to equip humanity not just to detect signals, but to communicate effectively across intergalactic spaces. Achieving this would require advancements in quantum computing, artificial intelligence, and radio astronomy, as well as breakthroughs in propulsion technology if we ever hope to explore the signal source directly. Another significant consequence of this discovery involves the moral and ethical questions it raises. What rights and responsibilities do we have when interacting with another intelligent species? If the Andromeda signal is a deliberate attempt at communication, it opens up ethical debates that philosophers and scientists have pondered for centuries. Should we respond? If so, how should we go about it? What form would our response take? Intergalactic communication presents unique dilemmas. For one, we don't know the signal's intent. It could be a friendly greeting, an observation, a warning, or something entirely beyond our understanding. There's also the issue of whether humanity is prepared for such a discovery. Historically, encounters between advanced and less technologically developed societies on Earth have often resulted in adverse outcomes for the latter. Could humanity find itself as the less advanced civilization in this cosmic encounter? Kaku frequently points out that our technological sophistication might be rudimentary compared to an intergalactic civilization. What if this civilization is billions of years ahead of us? They might regard us with the same curiosity and detachment that we have when studying microorganisms. This notion raises uncomfortable questions about intelligence and power dynamics in the universe. He often refers to the Kardashev scale when discussing potential hierarchies of civilizations. This scale measures a civilization's technological advancement based on its energy consumption. Currently, humanity is a Type 0 civilization, relying solely on planetary resources. A Type 1 civilization can harness all the energy of its home planet, a Type 2 can utilize the energy of its entire star, and a Type 3 can command the energy of an entire galaxy. If the Andromeda signal comes from a civilization that's Type 2 or 3, it challenges us to consider how such an advanced society might perceive us. The technologies they possess, artificial intelligence, faster-than-light communication, perhaps even interstellar travel, could defy our current understanding of physics. While this could lead to a renaissance of scientific discovery on Earth, it could also provoke fear and paranoia. History shows that fear of the unknown can lead to irrational actions. On a cultural level, this discovery could prompt a period of deep introspection. It forces us to confront existential questions that have lingered for millennia. Why do we exist? What is our role in the universe? Are we meant to join a larger galactic community, or are we destined to remain isolated observers? If the signal originates from an intelligent species, it might offer insights into how another civilization has addressed these fundamental questions. They may have overcome challenges like war, inequality, and environmental degradation, providing a model for how humanity might evolve. Conversely, their experiences could serve as a warning about the pitfalls of unchecked technological progress. Political implications. Religious and spiritual communities around the globe are likely to feel the impact of this discovery profoundly. Many belief systems posit that humanity holds a unique place in the universe, possibly as the sole intelligent life. The possibility of other intelligent beings, especially ones far older and more advanced, could challenge foundational doctrines. How will different religions reconcile the existence of extraterrestrial intelligence with their teachings? This could lead to a crisis of faith for some, while others might find that it expands their understanding of the divine. The discovery also opens up philosophical debates about consciousness and the soul. If other intelligent beings exist, what is the nature of their consciousness? Do they possess self-awareness, emotions, a sense of morality similar to ours? Or are they fundamentally different in ways we can't yet comprehend? Politically, the Andromeda signal could have far-reaching consequences. Governments worldwide would likely scramble to interpret the signal and control the narrative. International organizations like the United Nations might become forums for intense debate about the appropriate course of action. Should humanity unite to decode the message and decide on a response? Or will nations pursue their agendas? The discovery could either foster unprecedented global cooperation or exacerbate existing tensions, particularly among superpowers with advanced space capabilities. Countries might compete to be the first to decode the signal, hoping to gain technological or strategic advantages. This could lead to a new kind of space race, not just about exploration, but also about securing potential benefits from any new technologies derived from the signal. National security concerns would also come into play. Governments would need to consider the risks of responding. Could acknowledging the signal make us vulnerable to hostile extraterrestrial forces? The militarization of space, already a concern, could accelerate as nations invest in defense systems against hypothetical threats. National security implications. The economic implications are equally significant. The burgeoning space economy could receive a substantial boost as both governments and private companies invest in technologies to detect, decode, and possibly respond to extraterrestrial communications. New industries could emerge, focusing on interstellar communication technologies, advanced propulsion systems, and more sophisticated space exploration tools. Intellectual property resulting from decoding the Andromeda signal could become a highly valuable asset. Universities, research institutions, and private companies might engage in fierce competition over patents and proprietary technologies. This could spur innovation, but also lead to legal and ethical disputes over ownership and access to these advancements. However, this rapid expansion into space brings risks. There could be unintended consequences like environmental harm to other celestial bodies or increased militarization of space. Ethical considerations about exploiting extraterrestrial environments would become more pressing. Beyond these immediate concerns, the signal invites us to ponder the nature of life and intelligence in the universe. What kind of intelligence could have sent this signal? It's possible that the signal doesn't come from biological beings, but from artificial intelligence created by a civilization that may no longer exist. Kaku and other futurists have speculated that advanced civilizations might reach a point where they can upload their consciousness into machines, achieving a form of immortality. If the signal comes from such a machine intelligence, it challenges our understanding of life itself. Another intriguing possibility is that the signal represents an attempt at interstellar diplomacy. Perhaps a civilization in Andromeda is part of a larger coalition of intelligent species spread across the universe, and this signal is an invitation to join them. This concept, a staple in science fiction, edges closer to reality with this discovery. However, integrating into a galactic community poses its own challenges. How would humanity, with its myriad political, religious, and cultural differences, present a unified front? Would we be accepted as equals, or might we find ourselves subordinate to more advanced species? As the world grapples with the implications of this signal, the event continues to push the boundaries of our knowledge and imagination. Each day brings new discussions, research avenues, and speculative theories. Scientists, technologists, and thinkers are deeply engaged in contemplating the long-term effects of this potentially transformative moment. The complexity of the signal and the vast array of possible explanations force us to reevaluate our assumptions about our place in the universe. One of the most immediate questions is what kind of intelligence could have sent this signal? Our understanding of intelligence is limited, based largely on our own species. We tend to project human cognitive and social traits onto hypothetical alien civilizations. But what if the intelligence behind the Andromeda signal is so different from ours that it's almost incomprehensible? This possibility is one of the most fascinating aspects of the discovery. If the signal is artificial, it might represent a form of intelligence operating under entirely different biological, cognitive, or technological frameworks. Communicating with such an entity would be an unprecedented challenge. The diversity of life on Earth provides only a hint of what's possible. Even among Earth's species, there are vastly different ways of processing information and perceiving reality. Dolphins use echolocation, bees communicate through complex dances. The intelligence behind the Andromeda signal might utilize forms of communication that are entirely alien to us, perhaps involving dimensions of physics we have yet to discover. This leads to the crucial task of language and decoding. Historically, breaking language barriers between human cultures has been a significant hurdle. Decoding a message from another species, potentially from another galaxy, presents an exponentially greater challenge. Scientists like Kaku speculate that we might start by identifying universal constants, such as mathematical principles or physical laws, as a common language. For example, sequences of prime numbers or patterns like the Fibonacci sequence could serve as initial points of connection, given that mathematics is considered a universal language. However, even this assumes that the other intelligence perceives the universe in a way that's compatible with our own understanding. Our efforts to decode the signal will likely rely heavily on advanced artificial intelligence and machine learning technologies. The complexity of the patterns might be beyond human cognitive capabilities, necessitating sophisticated algorithms to identify and interpret potential meanings. Training AI to simulate various alien cognitive models could expand our ability to make sense of the data. As we undertake this monumental task, the question of whether to respond looms large. Some experts advocate for caution, suggesting we should focus on understanding the message fully before deciding on any course of action. Others argue that the chance to engage with an advanced civilization is too significant to delay, despite the risks. The decision to respond ties back to the issue of trust. We cannot assume that an extraterrestrial civilization shares our values or even has a concept of values that we can recognize. Establishing common ground might be one of humanity's greatest challenges. Kaku and others suggest looking to our history for guidance, but human encounters between disparate societies have often resulted in exploitation and conflict. This historical context underscores the need for a cautious and ethical approach. This is where the idea of cosmic humility becomes vital. Recognizing that we may not be the most advanced beings in the universe can be both humbling and inspiring. It opens the door to learning and growth, potentially accelerating our scientific and technological development. The Andromeda signal may also compel us to reassess our notions of progress. If we encounter a civilization that has evolved along a different path, perhaps prioritizing sustainability or social harmony over technological dominance, it could challenge our assumptions about what it means to advance. Simultaneously, the signal acts as a mirror, reflecting our unresolved issues back at us. Global challenges like climate change, inequality, and geopolitical tensions demand our attention. How can we aspire to engage with an advanced alien civilization when we're still grappling with problems here on Earth? The discovery might serve as a catalyst for uniting humanity to address these pressing concerns. In terms of international relations, crafting a response to the signal would require unprecedented global cooperation. A message to another galaxy represents all of humanity, necessitating a collective effort to define what we want to communicate about ourselves. The cultural impact of the discovery is immense. It could inspire a new wave of creativity across art, literature, and media as we explore what it means to be human in a universe potentially filled with life. Educational systems might adapt to include new disciplines focused on astrobiology, extraterrestrial communication, and interstellar diplomacy. If you found this discussion intriguing, please like and subscribe for more insights. We'd also love to hear your thoughts. What do you think the signal from Andromeda could be? Share your ideas in the comments below. Thank you for joining us, and we'll see you next time.
Hope we go back to the moon soon. We should have a base on the moon, like a permanently occupied human base on the moon, and send people to Mars, and build a city on Mars. That's what we should do.
In a universe teeming with enigmas and unexplored frontiers, Elon Musk, the visionary entrepreneur and founder of SpaceX, has consistently pushed the limits of technology and exploration. But what if we told you he believes the moon harbors secrets beyond our wildest dreams? Does Elon Musk possess knowledge we're unaware of? And is there a larger scheme unfolding? Join us on a mind-expanding journey as we delve into Elon Musk's psyche and uncover the hidden truths about Earth's closest celestial neighbor. The allure of outer space's mysteries continues to captivate humanity's brightest minds. This is why numerous space agencies have intensified their exploration plans for the coming decade. Nations like the United States, China, and Russia are deeply involved in these ventures. Even private companies like Elon Musk's SpaceX have joined the race, leading to collaborations among them. Recently, a fascinating partnership emerged between Elon Musk and China. Following leaks from the Tesla and SpaceX CEO, a startling discovery made by China on the moon's far side was revealed. This finding raises questions about what China uncovered and why it was concealed. Could this be evidence of extraterrestrial life? The China National Space Administration has been making significant strides in space exploration, challenging NASA's dominance. China has even built its own space station, adding to its impressive accomplishments. During their lunar missions, China stumbled upon a remarkable discovery, a secret that Elon Musk later shared with the world. In response, the China National Space Administration and the China Atomic Energy Authority issued an official announcement addressing the leaked information and revealing the astonishing news globally. The announcement disclosed that Chinese scientists, during their lunar research, made a groundbreaking breakthrough. They unearthed the sixth new lunar material, named Chang'e. This extraordinary mineral was discovered by researchers at the Beijing Research Institute of Uranium Geology, while examining surface samples collected by China's Chang'e 5 robotic mission. To confirm its uniqueness, the material was certified by the International Mineralogical Association and its Commission on New Minerals, Nomenclature, and Classification. Musk noted that Chang'e, belonging to the lunar marilite category, holds special importance. It marks the first lunar material discovered and observed by Chinese scientists, placing China alongside the United States and Russia as the third nation to achieve such a significant find. The mineral sample, a single crystalline particle measuring just 10 microns in diameter, was meticulously separated from over 140,000 tiny particles. It then underwent thorough analysis using advanced mineralogical techniques. The mission that led to this incredible discovery was the Chang'e 5 robotic expedition. This groundbreaking journey was launched from the Wenchang Space Launch Center in South China's Hainan province. After an awe-inspiring voyage, it successfully landed on the moon, becoming the third spacecraft in the 21st century to do so, following China's Chang'e 3 and Chang'e 4. This space mission, lasting 23 days, proved to be one of China's most daring and challenging ventures into space. Its goal was to collect lunar rocks and soil, and it triumphantly returned with 1,731 grams, a monumental achievement. Remarkably, it had been 46 years since the last lunar materials were brought back from our celestial neighbor. The China National Space Administration oversaw the distribution of the first batch of lunar samples obtained by Chang'e 5. These samples, each weighing 17.5 grams, were carefully divided into 21 lots and provided to researchers from 13 domestic institutions. These esteemed scientists were working on an impressive array of 31 lunar-related scientific projects. This accomplishment etched China's name into the annals of history. Collaboration was crucial in this monumental endeavor, as experts from various departments, including the Chinese Academy of Sciences, Ministry of Education, and Ministry of Natural Resources, united to study the moon samples. Their research revealed that these tiny moon crystals are over 1 billion years old, with a width comparable to a human hair. Such a profound revelation deepens our understanding of the moon's geological history and composition, paving the way for further scientific exploration and discovery. The remarkable findings from the Chang'e 5 mission left scientists at the International Mineralogical Association astounded. Their analyses confirmed that the tiny moon crystal has a composition unlike anything previously seen. It is intricately linked to other minerals found exclusively on the moon or within meteorites. These significant milestones have not only enhanced our understanding of the moon's origin and evolution, but also laid the groundwork for exploring the effective use of lunar resources. However, this astonishing revelation wasn't the only surprise from the moon mission. Another groundbreaking discovery caught the attention of Musk, a prominent advocate for clean energy. Among the approximately 140,000 lunar particles examined from the Chang'e 5 moon rocks, scientists found traces of helium-3. This form of helium is rare on Earth, but is believed to be abundant on the moon. It has been envisioned as a potential fuel source capable of revolutionizing the production and use of clean and efficient energy on our planet. This sheds light on why Musk chose to leak this information to the public. For years, scientists have been fascinated by helium-3 and its potential as a fuel for nuclear fusion, a remarkable energy production process where two light atoms combine to form a heavier one under extreme heat and pressure. The prospect of harnessing helium-3 for nuclear fusion has sparked great interest. Its unique properties and abundance on the moon open possibilities for a future energy revolution. Musk's decision to share this information signifies its potential to transform our energy landscape, paving the way for cleaner, more sustainable, and efficient energy generation. While fusion naturally occurs in stars' cores, scientists have yet to develop a fusion reactor that produces more energy than it consumes. However, helium-3 emerges as a highly promising fuel source, producing significantly less radiation and nuclear waste than other elements. According to Musk, helium-3 does exist on Earth, but in limited quantities. In contrast, it's believed to be more abundant on the Moon, where the solar wind has deposited it onto the lunar soil over billions of years. The European Space Agency highlights that despite the lack of viable reactors to use helium-3, a lunar resource race has already begun. Numerous spacefaring nations and private companies, including the United States and China, have shown keen interest in mining the Moon for helium-3. The discovery of a new helium-3 deposit by Chang'e 5 could accelerate the global competition to exploit the Moon's mineral resources. This revelation has undoubtedly pushed the boundaries of space exploration and resource utilization. Beyond his endeavors in clean energy, Musk has revealed plans to establish human settlements on the Moon as part of his vision to expand human civilization beyond Earth. His ambitious plans align with the growing belief that the Moon holds great potential for sustaining human life. Moreover, Chang'e 5's further exploration of the lunar surface led to the detection of water. This finding raises the exciting possibility of humanity surviving and thriving on the Moon. The presence of water opens doors for sustaining future lunar missions and establishing long-term human presence, further stimulating scientific curiosity and exploration. For many years, scientists believed the Moon to be a dry, waterless, celestial body. However, thanks to the Chinese lunar lander, a groundbreaking discovery was made: water on the Moon's surface. This isn't mere speculation. Scientists have confirmed water's presence on the lunar terrain. During its mission, Chang'e 5 collected over 60 ounces of soil and rock samples, unveiling not only rare minerals, but also the remarkable finding of water. Before returning to Earth, Chang'e 5 used its onboard instruments to take crucial measurements. Even from 239,000 miles away, scientists deduced that the probe likely encountered water on the Moon. Water, vital for human survival, isn't typically expected in deep space. Its scarcity poses a significant challenge for exploring the final frontier, necessitating extensive preparations. This new discovery could revolutionize our understanding of lunar resources. To delve deeper, scientists conducted further research to investigate whether the trace amounts of water found could be harnessed by astronauts during extended missions. A team led by scientists from the Institute of Geology and Geophysics at the Chinese Academy of Sciences analyzed the wealth of data collected by Chang'e 5, seeking to unlock the secrets of lunar water. The intriguing findings from the data analysis revealed signs of water indicated by the probe's readings. Scientists identified H2O molecules based on how they reflected or absorbed the sun's radiation, known as spectral reflectance. These results impressed Dr. Meg Siegler, a senior scientist at the Planetary Science Institute in Tucson, Arizona. Dr. Siegler suggested there might be more water on the Moon than previously thought. These ongoing discoveries have reshaped scientists' understanding of lunar water. Contrary to initial assumptions after the Apollo astronauts returned in 1969, believing the Moon was entirely dry, subsequent missions have challenged this notion. The Indian Space Research Organization's Chandrayaan-1 mission, for example, detected signs of hydration on the sunless lunar surface. However, it was difficult to determine whether it was H2O or its chemical relative, hydroxyl. Casey Hannibal, a NASA postdoctoral fellow, compared hydroxyl to a substance found in drain cleaners, adding to the discovery's intrigue. Further missions uncovered ice in hard-to-reach craters near the Moon's poles. These perpetually shadowed craters provide conditions favorable for preserving ice. Such findings prompted scientists to revisit Apollo samples with renewed curiosity. During analysis, water molecules were detected within glass beads and minerals in the samples, bringing both excitement and confusion as it challenged the moon's perceived dryness. Some scientists were skeptical, questioning whether the water originated from the moon or was due to moisture contamination on Earth. However, subsequent evidence emerged. A month before the Chinese lander's discovery, NASA announced the existence of water in a sunlit region of the moon. Without landing on the lunar surface, NASA achieved this by sending a high-altitude aircraft called SOFIA up to 45,000 feet. From this vantage point, SOFIA used advanced infrared technology to observe specific wavelength signals emitted by water molecules. The telescope's findings suggested water might be widespread across the moon, not just at the poles as previously thought. The mystery deepened when China's Chang'e 5 mission made another intriguing discovery. Besides shedding light on unresolved phenomena, the rover U-2 debunked certain mysteries, including the so-called Mystery Hut found on the moon in November 2021. Initially spotted from a distance, the small square object resembled a hut, sparking curiosity. Scientists sent the rover for a closer look. As U-2 approached, it became clear it wasn't a man-made structure, but an ordinary moon rock. The rock, later named the Jade Rabbit, due to its rabbit-like appearance, had created an illusion through light and shadow. Therefore, Musk, the visionary behind SpaceX, is tirelessly working toward his ambitious goals, including helping NASA return to the moon by 2025. However, China also harbors long-held aspirations to establish a lunar presence, not just to claim a moon base, but also to propel nuclear-powered rockets into space in the future. They believe this will pave the way for colonization and enhance exploration of the final frontier. China's efforts haven't gone unnoticed, as they plan to build their first moon base by 2028 and send astronauts there in subsequent years. The moon base will be a remarkable feat, powered by nuclear energy to meet its long-term power needs. Its design will include a lander, hopper, orbiter, and rover, all constructed through the Chang'e 6, 7, and 8 missions. Wu Weiren, the chief designer of China's lunar exploration program, confidently predicts that Chinese astronauts will set foot on the moon within a decade. Regarding the use of nuclear energy to power the base, he asserts it's the best option for meeting the station's energy requirements. China's accomplishments have put them in the global spotlight, from successful lunar probes to building their own space station and preparing for Mars exploration. Their ambitious plans position them as formidable competitors to NASA's dominance in space exploration. Meanwhile, NASA continues to make strides, with a rover on Mars and plans to send astronauts back to the moon within this decade. Both China and the United States are investing billions in lunar missions, not only to explore the moon and its resources, but also to advance space travel to Mars. China's focus is on constructing a moon base at the lunar South Pole, deemed most suitable for accessing water, an essential resource. They also envision expanding their base into an international research station. With this goal, China has set forth a roadmap for robotic lunar and deep space exploration. Upcoming missions will deploy landers, orbiters, and relay satellites, testing key technologies needed for constructing the International Lunar Research Station in the 2030s. Initially, the ILRs will serve as a robotic base, becoming permanently habitable after 2035. In the coming years, China is set to make significant strides in lunar exploration. Building on the success of the Chang'e 5 mission in 2020, Chang'e 6 is planned as a follow-up mission for 2026. It aims to retrieve up to 2 kilograms of material from the lunar far side's South Pole Aitken Basin. To overcome engineering challenges, the landing site will likely be near the same latitude as the Chang'e 4 mission's landing in the Von Karman crater. A new lunar relay satellite will be launched to ensure seamless communication, targeting the moon's South Pole vicinity. Around the same time, Chang'e 7 will launch, equipped with an orbiter, lander, rover, and a mini flying detector. This comprehensive mission will study lunar topography, material composition, and the environment. The mini flying detector will play a crucial role in identifying water ice, focusing on permanently shadowed areas in the lunar South Pole. These missions aim to unlock the secrets of the moon's unexplored regions. Looking further ahead, Chang'e 8 is projected to launch by 2028, serving as a testbed for in-situ resource utilization and 3D printing technologies. This mission signifies China's commitment to exploring the potential of utilizing lunar resources and advancing cutting-edge technologies. China is also preparing for a crewed lunar landing in 2030, planning to send 3 astronauts to the moon. This ambitious endeavor will involve 2 launches of a new generation crew launch vehicle. 2 astronauts will have the opportunity to set foot on the lunar surface for about 6 hours, conducting experiments and gathering valuable data. Both lunar landers and spacecraft for this mission are currently under development to support these extensive plans. The China International Lunar Research Station will be established in the early 2030s. The ILRS will see 5 launches dedicated to placing orbital and surface infrastructure for energy, communications, resource utilization, and other advanced technologies. These missions will require the lifting power of the Long March 9, a super heavy lift rocket. Excitingly, Chinese officials have announced they're redesigning the Long March 9 to make it reusable. While it's certain that Musk is involved in lunar projects, it's also clear that the Chinese Space Agency has a bright future ahead, with numerous discoveries and advancements on the horizon. As this journey into Elon Musk's enigmatic world and his discoveries about the moon continues, one thing is abundantly clear: the moon isn't what we thought it was. Musk's vision and relentless pursuit of knowledge have opened our minds to a universe of possibilities. Experts suggest that the moon's secrets might just be the beginning, and our universe remains full of awe-inspiring wonders that could shake the very foundations of our understanding of the cosmos. The night sky is poised for a dramatic change as Antares, a red supergiant 700 times larger than our Sun, nears the end of its life. On the verge of a supernova, its explosion could outshine even Betelgeuse and rival the brightness of our entire galaxy. As we await this cosmic event, one question remains: what will happen when this stellar giant finally erupts?
So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Is a supernova, first of all?
A supernova is an exploding star.
They are among the biggest explosions of radio energy in the entire universe.
Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Observable supernovae within our galaxy are exceedingly rare. The last recorded instance occurred centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This impending celestial display offers astronomers and space enthusiasts a unique opportunity to witness cosmic history unfold before their eyes. As we embark on this journey through the cosmos, we'll explore the far-reaching impacts of this stellar explosion. From the creation of heavy elements to the potential formation of neutron stars or black holes, the aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant. Antares, a red supergiant located approximately 604 light-years from Earth, is a cosmic behemoth that captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our Sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many observers of the night sky. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, are a testament to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the Scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching several % of the speed of light. To put this into perspective, imagine a mass several times that of our sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shock waves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for heavy elements. The intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects, where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, no supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernovae in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Corona Borealis. This system consists of a red giant star and a white dwarf, locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Corona Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Corona Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Corona Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Corona Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal, These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust, forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernovae and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins and place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet, despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this: the last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our earthly vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, it would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of Antares supernova would be a game changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernova across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe.
From the outside, you can't tell what is inside a black hole.
What if everything you know about the universe is inside out? Recent theories suggest our entire cosmos could be nestled within a black hole. This mind-bending concept challenges our understanding of space and time, proposing that the very fabric of our reality might be contained within what we once thought was a cosmic destroyer.
So your feet approach the black hole faster than your head does.
Okay.
You snap into
Right.
two segments. Then each of those two segments,
Right.
eventually they snap into two segments. You
Right.
go from 1 to 2 to 4 to 8
Right.
to 16, and you're the stream of particles descending down
Now,
to
is
the
that,
abyss.
are you feeling pain or you're not?
Yeah.
And in fact, if you want to see a black hole tonight, go outside, look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the sun, lurking right at the center of our own backyard.
Black holes, those mysterious cosmic entities, have long been a source of fascination for scientists and stargazers alike. These gravitational behemoths, known for their insatiable appetite for matter and light, might hold secrets beyond our wildest imaginations. But what if they're more than just cosmic vacuum cleaners? What if our entire universe exists within one? This audacious theory raises a central question. Could our entire universe be inside a black hole? It's a concept that turns our perception of reality on its head, challenging everything we thought we knew about the cosmos. As we embark on this journey of cosmic exploration, prepare for revelations that will stretch the limits of your imagination and redefine our place in the universe. Black holes, cosmic destroyers or creators. Black holes have long been viewed as the ultimate cosmic destroyers, voracious entities that consume everything in their path. This perception stems from their most defining characteristic, a gravitational pull so intense that nothing, not even light, can escape once it crosses the event horizon. But what if these cosmic giants are more than just nature's perfect vacuum cleaners? To understand the potential creative role of black holes, we must first explore their formation and nature. Black holes are born when massive stars collapse under their own gravity at the end of their lives. As the star's core implodes, it becomes incredibly dense, creating a gravitational field so strong that it warps the very fabric of space-time around it. This results in the formation of an event horizon, the point of no return beyond which nothing can escape the black hole's grasp. The immense gravitational pull of black holes is a testament to their power. Imagine a force so strong that it can bend light itself, creating a cosmic funhouse mirror effect around its edges. This gravitational lensing, as it's called, is one of the ways astronomers detect and study these elusive cosmic entities. But black holes aren't just found in isolation. In fact, they play a central role in the structure of our universe. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. These cosmic behemoths can have masses millions to billions of times that of our sun, exerting a gravitational influence that shapes the very galaxies they inhabit. The presence of these supermassive black holes at galactic centers has led scientists to question their role in cosmic evolution. Are they merely the end result of galactic formation, or do they play an active part in shaping the universe we see today? This question challenges the traditional view of black holes as purely destructive forces. While it's true that their gravitational pull is immense, black holes are surprisingly inefficient at capturing matter from large distances. They only consume objects that venture very close to their event horizons. This selective appetite suggests that black holes might have a more nuanced role in cosmic processes than previously thought. In fact, black holes can be sources of incredible energy and cosmic phenomena. When material falls towards a black hole, it forms a swirling disk of gas and dust called an accretion disk. As this material heats up to millions of degrees, it releases enormous amounts of energy in the form of radiation. This process can create some of the brightest objects in the universe, such as quasars and active galactic nuclei. These energetic processes associated with black holes hint at their potential creative power. The radiation and jets emitted by active black holes can influence star formation and galactic evolution, shaping the cosmic landscape around them. In this light, black holes begin to look less like cosmic destroyers and more like cosmic architects, playing a crucial role in the ongoing story of our universe. The idea that black holes might be creators rather than just destroyers opens up fascinating possibilities. Could these cosmic entities be more than just the endpoint of stellar evolution? Might they, in fact, be the birthplaces of new universes? This concept challenges our understanding of the cosmos and raises intriguing questions about the nature of reality itself. If black holes can create new universes, could our own universe be nested within a larger black hole? And if so, what implications does this have for our understanding of space, time, and the fundamental laws of physics? The universe within, a new perspective. The idea that our entire universe could be nestled within a black hole is a concept that challenges our fundamental understanding of reality. This theory proposes that the cosmos we observe and inhabit might be contained within the event horizon of a massive black hole in a larger, parent universe. It's a perspective that requires us to reconsider our notions of space, time, and the very fabric of existence. To grasp this concept, imagine our universe as a bubble floating in a vast cosmic ocean. In this analogy, the surface of the bubble represents the event horizon of a black hole, and everything we know and experience exists within this bubble. The ocean surrounding it would be the larger universe or multiverse that contains our black hole universe. This theory stems from the similarities between the properties of our universe and those of black holes. Both exhibit extreme densities, intense gravitational effects, and mysterious singularities at their cores. The Big Bang, which marked the birth of our universe, shares characteristics with the formation of a black hole, suggesting a possible connection between these cosmic phenomena. One of the key principles supporting this theory is the concept of quantum gravity. This theoretical framework attempts to reconcile quantum mechanics with Einstein's theory of general relativity. In the realm of quantum gravity, the extreme conditions inside a black hole could potentially give rise to a new universe with its own set of physical laws and constants. The implications of this theory are profound. If true, it would mean that the laws of physics as we know them might only apply within our universe bubble. Beyond the event horizon of our cosmic black hole, entirely different rules could govern reality. This concept challenges our understanding of causality and the arrow of time, as events in the parent universe might influence our own in ways we cannot yet comprehend. To visualize this complex idea, consider a Russian nesting doll. Each doll represents a universe contained within a black hole of a larger universe. Our cosmos would be one of these dolls, with potentially infinite layers of reality both above and below us. This nested structure could explain the hierarchical nature of cosmic structures we observe, from subatomic particles to galactic superclusters. The black hole universe theory also offers potential explanations for some of the most perplexing mysteries in cosmology. For instance, it could account for the apparent flatness and uniformity of our universe, as the interior of a black hole would naturally create such conditions. It might also provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of the universe. Moreover, this concept aligns with the idea of cosmic inflation, the rapid expansion of the universe in its earliest moments. The intense gravitational forces at the event horizon of a black hole could produce an effect similar to cosmic inflation, explaining the uniform distribution of matter and energy we observe in our universe. However, it's crucial to note that this theory remains highly speculative. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This highlights the significant gaps in our knowledge regarding black holes and their implications for understanding the universe. Cosmic incubators, black holes as universe generators. As we venture deeper into the cosmic mysteries surrounding black holes, a revolutionary idea emerges. These enigmatic objects might not just be destroyers of matter, but creators of entire universes. This concept transforms our understanding of black holes from cosmic dead ends to cosmic incubators, potentially giving birth to new realms of existence. The notion of black holes as universe generators stems from the complex interplay between quantum mechanics and gravity. At the heart of this theory lies the concept of Hawking radiation, proposed by the renowned physicist Stephen Hawking. This phenomenon suggests that black holes aren't entirely black, but emit a faint glow of particles over time. Hawking radiation occurs due to quantum effects near the event horizon of a black hole. In this region, pairs of particles and antiparticles spontaneously pop into existence. Normally, these pairs would quickly annihilate each other. However, near a black hole's event horizon, one particle might fall into the black hole while the other escapes, appearing to be emitted by the black hole itself. This process has profound implications for our understanding of black holes and the universe at large. Over extremely long periods, Hawking radiation could cause black holes to slowly evaporate and shrink. This evaporation process might seem to contradict the idea of black holes as universe creators, but it's precisely this mechanism that opens up intriguing possibilities. As a black hole evaporates, it becomes smaller and denser. Some scientists propose that when a black hole reaches a critical size, the immense gravitational forces and quantum effects could trigger the formation of a new universe. This new cosmos would be born from the singularity at the center of the black hole, expanding into its own space-time separate from our own. In this scenario, black holes act as cosmic recycling machines. They consume matter and energy from one universe, only to use that material as the seeds for a new universe. This process creates a fascinating cycle of cosmic birth, death, and rebirth. The implications of this theory extend far beyond a single universe. If black holes can indeed generate new universes, it suggests the existence of a vast cosmic network. Our universe might be just one of countless others, each born from a black hole in a parent universe. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. Imagine a cosmic tree with each branch representing a universe and each leaf a black hole. These leaves might sprout new branches, creating an ever-expanding structure of interconnected realities. In this model, our universe could be a single branch on an infinitely complex cosmic tree. This theory also provides a potential explanation for the fine-tuning of our universe. The physical constants and laws that govern our cosmos seem perfectly balanced to allow for the existence of complex structures like galaxies, stars, and life. If our universe is one of many born from black holes, it's possible that each new universe inherits slightly different properties from its parent. Over time, this cosmic natural selection could result in universes increasingly capable of supporting complex structures. However, it's important to note that while these ideas are intellectually stimulating, they remain highly speculative. As one researcher points out, the surprising new insights show that there is still much to learn about black holes. Our current understanding of black holes, quantum mechanics, and the nature of the universe is still limited, and these theories push the boundaries of our knowledge. The concept of black holes as universe generators also raises fascinating philosophical questions. If our universe is indeed nested within a larger black hole, what does that mean for our understanding of reality? Are there layers of existence beyond our perception? Could the physical laws we observe be merely local phenomena, with entirely different rules governing the larger multiverse? Living in a black hole, what it means for us. The idea that we might be living inside a black hole seems like something out of science fiction. Yet this theory has gained traction among some physicists, challenging our fundamental understanding of the cosmos. If true, it would revolutionize our perception of reality and our place within it. Living in a universe inside a black hole would have profound implications for our understanding of space and time. The laws of physics as we know them might only apply within our cosmic bubble, with entirely different rules governing the larger reality beyond our event horizon. This concept challenges our notions of causality and the arrow of time, suggesting that events in a parent universe could influence our own in ways we cannot yet comprehend. One of the most intriguing aspects of this theory is its potential to explain certain cosmic phenomena we observe. The apparent flatness and uniformity of our universe, for instance, could be a natural consequence of existing within a black hole. The intense gravitational forces at the event horizon could produce effects similar to cosmic inflation, accounting for the uniform distribution of matter and energy we see around us. Moreover, this theory might provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of our universe. If our cosmos is indeed nested within a black hole, the expansion we observe could be a result of our universe's growth within its host black hole. This perspective offers a fresh approach to one of the most perplexing mysteries in modern cosmology. The black hole universe theory also opens up fascinating possibilities regarding parallel universes in alternate dimensions. If our universe is one of many born from black holes, it suggests the existence of a vast cosmic network of interconnected realities. Each black hole in our universe could potentially be the birthplace of a new cosmos, creating an infinite fractal structure of nested universes. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. In this model, our universe might be just one branch on an infinitely complex cosmic tree, with each leaf representing a black hole capable of sprouting new universal realities. The implications of such a structure are mind-boggling, suggesting layers of existence beyond our current perception. However, it's crucial to acknowledge the limitations of our current understanding and technology. While these theories are intellectually stimulating, they remain highly speculative. Our knowledge of black holes, quantum mechanics, and the nature of the universe is still limited, and these concepts push the boundaries of our scientific understanding. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This statement underscores the significant gaps in our knowledge and the challenges we face in exploring these cosmic frontiers. Our current technology is far from being able to directly observe or test many aspects of these theories, leaving us in a realm of mathematical models and theoretical speculation. Despite these limitations, the idea of living in a universe inside a black hole offers exciting prospects for future research and exploration. It challenges us to think beyond our current paradigms and consider new possibilities for the nature of reality. This theory could potentially provide a unified framework for understanding various cosmic phenomena, from the Big Bang to the large-scale structure of the universe. If proven true, this concept would indeed revolutionize our place in the cosmos. It would suggest that our universe is part of a larger, perhaps infinite, cosmic structure. This perspective could fundamentally alter our understanding of creation, existence, and the very nature of reality itself. It raises profound philosophical questions about our significance in the grand cosmic scheme and the potential for other forms of life and civilizations existing in parallel universes. The horizon of discovery, what lies ahead? The journey to unravel the mysteries of black holes and their potential role as universe generators is far from over. Scientists are embarking on ambitious research projects and experiments to probe deeper into these cosmic enigmas. The quest to understand black holes and their implications for our universe remains one of the most exciting frontiers in modern physics. Current research focuses on several key areas. One primary goal is to detect and analyze gravitational waves produced by black hole mergers. These ripples in space-time offer valuable insights into the behavior and properties of black holes. Advanced detectors like LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo are at the forefront of this effort, capturing data from cosmic collisions billions of light years away. Another critical area of study involves observing the event horizons of black holes. The Event Horizon Telescope project, which captured the first ever image of a black hole in 2019, continues to push the boundaries of our observational capabilities. By combining data from multiple radio telescopes around the globe, scientists aim to create even sharper images of black holes and their surrounding environments. However, the path to proving or disproving the black hole universe theory is fraught with challenges. The very nature of black holes makes direct observation of their interiors impossible with current technology. The intense gravitational fields and extreme conditions near the event horizon pose significant obstacles to gathering data. Moreover, the scales involved in these theories are mind-boggling. If our universe is indeed nested within a larger black hole, the parent universe would exist on a scale far beyond our current observational limits. This raises fundamental questions about the nature of scientific inquiry and the limits of human knowledge. Despite these hurdles, scientists remain undaunted. They are developing new theoretical frameworks and mathematical models to bridge the gap between quantum mechanics and general relativity. These efforts aim to create a unified theory of quantum gravity, which could provide crucial insights into the behavior of black holes and the potential for universe generation. Technological advancements will play a crucial role in future explorations. More sensitive gravitational wave detectors, improved space-based telescopes, and in potentially even quantum computers could revolutionize our ability to study cosmic phenomena. These tools may allow us to probe deeper into the nature of black holes and test the predictions of various theoretical models. The implications of these discoveries extend far beyond the realm of physics. The concept of a black hole universe challenges our fundamental understanding of reality, space, and time. It raises profound philosophical questions about the nature of existence and our place in the cosmos. If our universe is indeed one of many nested within black holes, it suggests a vastness to reality that is difficult to comprehend. It opens up possibilities for parallel universes, alternate dimensions, and forms of existence beyond our current imagination. This perspective could reshape our understanding of creation, evolution, and the very fabric of reality. The ongoing exploration of black holes and their potential role as universe generators serves as a testament to human curiosity and ingenuity. It pushes the boundaries of our knowledge and technological capabilities, driving innovation across multiple scientific disciplines. As we continue to peer into the cosmic abyss, we are reminded of the endless possibilities that await discovery. The universe, it seems, is far more complex and mysterious than we ever imagined. Each new revelation opens up new questions, fueling the endless cycle of scientific inquiry and exploration. A universe of wonder. The black hole universe theory challenges our fundamental understanding of reality. It suggests our cosmos might be nestled within a larger black hole, part of an infinite cosmic structure. This concept offers potential explanations for mysteries like dark energy and cosmic inflation. It also raises profound questions about the nature of existence and our place in the grand scheme. While highly speculative, this theory encourages us to think beyond our current paradigms. It reminds us that the universe is far more complex and mysterious than we imagine. As we continue to explore these cosmic frontiers, we're pushed to question our assumptions and expand our understanding. Perhaps one day, as one researcher speculates, we will know exactly what lies inside of a black hole. Until then, we remain in awe of the vast, unknown cosmos that surrounds us. Breaking news!
It will be years before that project becomes a reality. If it goes as planned, the journey to Proxima B will take about 20 years.
We may have just uncovered potential evidence that intelligent life exists beyond Earth. Moments ago, the telescope detected something strange that could potentially signal intelligent life beyond our planet. If this discovery proves authentic, we could be staring at undeniable proof that we are not alone in the universe. Aliens might actually exist, and this is the closest we've ever come to proving it. So what exactly did the James Webb telescope discover? Could it have communicated with extraterrestrial beings? Let's dive into what we know. The James Webb telescope has made an astonishing observation on Proxima B, an exoplanet that has sparked tremendous interest since its discovery in 2016. But what exactly makes Proxima B so fascinating? And why is it attracting so much attention from astronomers? First, let's break it down. Proxima B is located just 4.24 light-years away from Earth. In terms of space, that's right around the corner. It also orbits within what astronomers call the habitable zone of its star, Proxima Centauri. This zone refers to a region where conditions could potentially allow liquid water to exist, a key ingredient for life as we understand it. Naturally, scientists have been eager to explore this planet to see if it holds any clues about life beyond Earth. However, there's a catch. Proxima B orbits a red dwarf star, and red dwarfs are known to be less than hospitable. These stars are notorious for their violent solar flares, which could strip away a planet's atmosphere, rendering it exposed and possibly uninhabitable. Despite the seemingly promising conditions, many doubted whether Proxima B could actually support life. Still, astronomers were undeterred. They continued to investigate the planet in hopes of uncovering something groundbreaking. Then came the James Webb Space Telescope. One of its primary objectives is to observe the universe with unprecedented detail, surpassing its predecessor, the Hubble telescope. Equipped with advanced infrared instruments, it can detect even faint emissions from distant stars, galaxies, and of course, exoplanets. When scientists directed the telescope toward Proxima B, they aimed to learn more about its atmosphere, surface, and, just maybe, any signs of biological life. But what they found was something completely unexpected. Instead of identifying familiar substances like methane or water vapor, the telescope detected a faint glow emanating from Proxima B's night side. And here's the shocking part. This was no natural phenomenon like volcanic activity or auroras. The glow was steady and consistent, the kind of illumination you would expect from artificial lighting, like the lights of a city at night. This finding has left scientists astonished. Could this be a sign of an advanced civilization? Although it's too soon to draw any firm conclusions, the possibility that we've detected intelligent life is difficult to dismiss. Artificial lights are typically associated with developed civilizations, as seen from Earth's satellites in space. If Proxima B indeed shows signs of such artificial lighting, we could be looking at our first real indication that we're not alone in the cosmos. What do scientists make of this discovery, and what theories are emerging from it? The discovery of what could be artificial lights on Proxima B is nothing short of astonishing. If these lights truly are a product of advanced technology, it could mean that a highly evolved civilization either exists now or once existed on this exoplanet located just 4.24 light-years away from Earth. If this is the case, it would be the first time humanity has found direct evidence of extraterrestrial technology. It's not a minor discovery like bacteria or some simple life form. We could be talking about intelligent beings capable of altering their environment and perhaps building city-like structures. This is the kind of discovery that makes you pause and reflect on the vastness of the universe and how much remains unknown. But as exhilarating as this possibility is, it also raises an avalanche of questions. If these lights are indeed the work of a civilization, just how advanced could they be? Are we looking at a society similar to ours, facing its own technological advancements and challenges? Or could this civilization be far more evolved than we can currently comprehend? For instance, the lights detected by the James Webb telescope cover a considerable portion of the planet. This could indicate the presence of one large city or multiple smaller settlements spread across Proxima B. In either case, this suggests an organized society rather than random, isolated patches of light. Of course, this leads to another pressing question. How are these lights being powered? Could they be using a form of energy we are familiar with, like electricity generated from coal, solar, or wind energy? Or perhaps more intriguingly, have they developed an energy source so advanced that we cannot even fathom it yet? Since Proxima B orbits a red dwarf star, which is far dimmer and cooler than our sun, the inhabitants, if they exist, may have had to get creative in finding ways to power their society. Their energy systems could provide critical insights into solving our energy challenges here on Earth. But what if these lights are not from a flourishing civilization? What if they are the remnants of a society that once thrived but has since declined? It raises the possibility of internal conflicts, environmental disasters, or perhaps even cosmic events that led to their downfall. On the other hand, if this civilization is still thriving, it brings up the potential for direct contact between their world and ours. This prospect brings with it a host of challenges, not least of which is the question of whether we should attempt to make contact at all. History has shown us that encounters between civilizations, especially ones at different stages of development, can lead to unpredictable outcomes, ranging from collaboration to conflict. The numerous examples from our own history remind us to tread carefully. So if we do decide to reach out to this potential alien civilization, how should we proceed? Should we approach them with caution, perhaps in the same way we handle delicate diplomatic situations here on Earth? Or should we dive headfirst into making contact, regardless of the risks? The ethical and practical implications of such a decision are immense, and frankly, a little terrifying. This discovery also challenges our fundamental understanding of where life can exist. For the longest time, scientists believed that planets orbiting red dwarf stars were highly unlikely to support life. Red dwarfs are notorious for emitting powerful solar flares that could strip away a planet's atmosphere, leaving it barren. Yet here we are, with potential evidence that not only life, but intelligent life might be thriving under these harsh conditions. If this is true, it would dramatically alter the way we think about habitable zones in the universe and expand the range of places where life could exist. This discovery of potential artificial lights could completely reshape our understanding of where intelligent life might be found in the cosmos, and the implications are as profound as they are exciting. Red dwarfs are actually the most abundant type of star in our galaxy. With Proxima B orbiting a red dwarf, it raises an exciting possibility. If life can thrive there, it might also exist on countless other planets around red dwarf stars. This revelation could completely reshape our understanding of the cosmos. Suddenly, the universe seems a lot more crowded with potential worlds that could host life. Even the regions of space we once dismissed as uninhabitable may require a second look. So what does this groundbreaking discovery mean for the future of space exploration? The implications are enormous. Proxima B's proximity to Earth, at just 4.24 light-years away, makes it an enticing target for future missions. While that distance is immense by human standards, it is remarkably close in the grand scheme of the universe. Over the years, there has been growing interest in the idea of sending robotic probes or even crewed missions to nearby star systems. But now, with potential evidence of artificial lights on Proxima B, these plans could accelerate dramatically. Scientists may soon focus on developing advanced propulsion systems that would enable us to study Proxima B and its possible inhabitants more directly. What once seemed like a distant dream now feels like a tangible goal. This discovery of potential artificial lights makes the planet an even more compelling candidate for future exploration. The objective would be to gather detailed data, study the planet up close, and potentially confirm the presence of an intelligent civilization. Of course, this isn't the first time humanity has looked for signs of life beyond Earth. For decades, the search for extraterrestrial intelligence, SETI, has been listening for radio signals or other types of communication from distant civilizations. However, with this new discovery, we might need to change our approach. Instead of just listening for messages, we should also be scanning for other signs of advanced technology, like city lights or large-scale infrastructure that could reveal the existence of an intelligent species. Imagine this. What if there are other planets just like Proxima B, where signs of life might be evident not through sound, but through visible markers like artificial lighting or massive engineering projects? This breakthrough could represent the beginning of an entirely new chapter in the search for extraterrestrial intelligence, one that focuses on visual and structural cues from other planets. And it's not just the scientific community that's buzzing with excitement. This discovery has ignited the public's imagination in a way that few space-related events have in recent times. The idea that there could be an alien civilization close enough for us to detect their lights, maybe even their cities, is absolutely thrilling and awe-inspiring. People are genuinely excited about this possibility. They've been closely following the latest updates from the James Webb Telescope, eagerly anticipating what discoveries might come next. And really, who can blame them? This potential discovery has transformed the way we think about life in the universe, bringing the search for extraterrestrial civilizations to the forefront of our collective curiosity. Beyond the science and public fascination surrounding this discovery, there is a much deeper, more profound aspect to consider. The potential finding of an intelligent civilization on Proxima B forces us to reevaluate our position in the cosmos. For so long, humanity has perceived itself as the pinnacle of evolution, the dominant species. However, if Proxima B is indeed home to intelligent life, it changes everything. This realization might not only alter our self-image, but could also shift how we understand our responsibilities, not just to our planet, but also to the technology we develop. The implications are vast, and while it presents a lot to process, it may also drive humanity forward into new and exciting directions. That's not all. There are also risks to consider. How do we prepare ourselves for the possibility that an alien civilization exists just light years away? If these beings are technologically advanced, the challenges grow even more complex. The detection of potential artificial lights on Proxima B raises serious questions about what kind of society could have created them. Could we learn from their achievements, perhaps discovering how to create a sustainable, highly advanced civilization ourselves? On the flip side, they might serve as a cautionary example, warning us of the dangers that rapid technological progress can bring. Another disturbing thought arises. Could they perceive us as a threat? Just as we might be wary of them, they could be equally cautious of Earth. The prospect of establishing contact with an extraterrestrial society raises important concerns about our future, how we navigate our place in the universe, and how we manage the vast responsibility that comes with such encounters. It pushes us to think critically about what type of civilization we are and what we want to become as we venture further into space. What's clear is that if these lights are indeed evidence of a civilization, this could trigger unprecedented levels of international cooperation. Studying a planet so far away is far from a one-nation job. It will likely require the kind of global teamwork we've seen before, perhaps with initiatives like the International Space Station. Multiple countries would need to collaborate, pooling resources, expertise, and technology, all working toward the common goal of exploring Proxima B and possibly establishing contact. This could usher in a new era of international collaboration, particularly in space exploration. If Proxima B is truly home to an advanced society, the question arises, how have they managed to survive in such an unforgiving environment? Remember, Proxima B orbits a red dwarf star, Proxima Centauri, which is infamous for its intense solar flares. These flares can bombard the planet with deadly radiation, raising serious doubts about the survival of life there. But the steady artificial light detected suggests that the inhabitants of Proxima B may have developed ways to shield themselves from these hostile conditions. Perhaps they've engineered advanced technologies that allow them to regulate their atmosphere or safeguard their cities from radiation exposure. It's also possible they've adapted either biologically or technologically to endure these extreme environments. Whatever the case, this would offer us an entirely new perspective on how life can evolve in ways that we've never even considered. The potential for such adaptations provides a fascinating insight into the resilience of life across the universe, expanding our understanding of what is possible. And let's not overlook the lights themselves. What if the technology behind them represents something far beyond what we currently understand? We could be talking about energy sources that we haven't even begun to imagine yet. Think about antimatter reactors, zero-point energy, or perhaps harnessing the power of their star in ways that remain beyond our wildest dreams. The possibilities are staggering. The sheer intensity and distribution of these lights might offer some critical clues about the level of technological advancement this civilization has achieved. If they have truly tapped into energy sources far more advanced than anything we've come up with, it could drastically reshape what we think is achievable for our own future. We might need to rethink the boundaries of technological innovation entirely. There is also an intriguing cultural dimension to consider. The way these lights are distributed across the planet could reveal significant insights into the structure of their society. If the lights are evenly spread, that might indicate a highly interconnected global civilization. But what if the lights are concentrated in certain areas? That could suggest a world divided into city-states, nations, or even factions. By studying these patterns, we could learn a great deal about how this alien society functions, including their approach to urban development and technological priorities. Gaining an understanding of how this society operates would be crucial if we ever make contact. Are these beings peaceful explorers, eager to share their knowledge and discoveries? Or are they more isolationist, choosing to stay hidden from the rest of the universe? The mere existence of artificial lighting on such a scale suggests a civilization advanced enough to have possibly already ventured into interstellar travel. If that's the case, they may have explored other planets or star systems beyond Proxima Centauri long before we detected them. Another pressing question that keeps arising is the timing of this discovery. Since Proxima B is only 4.24 light-years away, the light we're seeing now left the planet just over 4 years ago. In cosmic terms, that's practically happening in real time. This proximity raises the fascinating possibility that any civilization on Proxima B could be experiencing technological progress at a pace similar to ours right now. They could be facing challenges and innovations that mirror our own, but in a completely alien context. Alternatively, this might be an older civilization that has already reached its technological zenith or even undergone some form of collapse, leaving the lights as remnants of what was once a thriving society. The close proximity of Proxima B also means that, despite the challenges of communication, any attempt to contact them would take significantly less time compared to communicating with civilizations in distant parts of the galaxy. With a communication delay of just over 4 years, it is almost instantaneous compared to the vast stretches of time that would be required for intergalactic communication with other star systems. If we do make contact, it could mark the beginning of a new era, one that transforms not only our understanding of ourselves, but also of life in the universe. So, what are the real possibilities that we might be able to establish contact with this new species? The potential for making contact with an alien civilization on Proxima B is nothing short of extraordinary. If we were to send out a signal, we could receive a reply in just 9 years. That's the incredible opportunity we are looking at here. For the very first time, humanity could engage in a real-time dialogue with another intelligent species. Of course, there are still enormous logistical challenges to overcome. What language would we use to communicate? And how would we even be able to ensure that we are truly understanding each other? These are big issues to consider, but the relatively short delay in communication, only 9 years, makes the idea far more plausible than it has ever been. And then we must ask ourselves, what other kinds of technology might they possess? We've already observed the possibility of artificial city lights on Proxima B, but what other signals or advanced technologies could be hiding there, still undetected? This might only be the start. Perhaps they have engineered massive structures that emit gravitational waves or something else entirely beyond our current understanding. Each new discovery could provide us with greater insights into their level of technology, and who knows, it might even offer us a blueprint for the future of our own technological development. Another massive question on everyone's mind is, what sort of beings live on Proxima B? If this civilization is advanced enough to create artificial lighting, it's almost certain that they are intelligent life forms. However, their biology might be something beyond anything we've ever encountered. Proxima B orbits a red dwarf star, a star that presents harsh environmental conditions. The inhabitants may have evolved with entirely unique biological traits in order to survive such an extreme climate. Alternatively, they might have gone beyond biology altogether, blending themselves with technology to become a post-biological society where machines and organic life have fused into a new species altogether. This also prompts us to rethink our definition of intelligence. For so long, we've evaluated intelligence based on our own human experiences, but what if the life forms on Proxima B have developed intelligence in an entirely different way? Perhaps they operate within a hive-like structure, or maybe their intelligence functions as a collective consciousness, a mode of thinking that we can't yet comprehend. This could totally reshape how we understand intelligence, and even challenge the way we think about AI and machine learning right here on Earth. But let's take it a step further. Imagine the astonishing possibilities of cultural exchange if we make contact with this alien civilization. Just think about it. The potential to share knowledge, exchange ideas, and learn from an entirely new species is overwhelming. They could introduce us to entirely new forms of governance, philosophy, art, and science, things that have evolved in completely different ways from what we know. This kind of collaboration could spark a new golden age of creativity, innovation, and thought for both their species and ours. So what do you think? How should we move forward with this groundbreaking discovery? Should we reach out and attempt to make contact with this extraterrestrial civilization, or should we hold back? We want to know your thoughts. Drop your opinions in the comments below. And if you're intrigued by stories like this one, don't forget to hit that subscribe button. There's plenty more to come, and you won't want to miss it. Thanks for watching, and goodbye.
The universe is teeming with planets outside our solar system, and each one offers a unique glimpse into the vast complexities of space. Enter the James Webb Space Telescope, Jwst, a marvel of modern science and a beacon of hope for astronomers searching for Earth-like planets. The JWST, with its unparalleled ability to peer into the depths of space through infrared eyes, has transformed our quest to understand distant worlds. Today, we're diving deep into one of JWST's most thrilling revelations yet, the discovery of Gliese 163c. This exoplanet, located in the habitable zone of its star, presents conditions that might just support life as we know it. Gliese 163c is not just another celestial body, it represents a potential future, a new chapter in human exploration, and perhaps the answer to the age-old question, are we alone in the universe? The telescope, the James Webb Space Telescope, JWST, stands as a pinnacle of astronomical technology equipped with tools specifically designed to observe distant exoplanets with unprecedented clarity and depth. Among its suite of sophisticated instruments, the near-infrared camera, NIRCam, is pivotal. NIRCam not only captures detailed images of exoplanets, but also analyses their atmosphere by observing the light passing through it when a planet transits its star. This helps identify elements that might indicate habitable conditions or even the presence of life. Another groundbreaking instrument aboard the JWST is the Mid-Infrared Instrument, MIRI. MIRI extends the telescope's vision further into the infrared spectrum, which is crucial for studying cooler celestial objects. This capability is vital for examining the thermal characteristics of an exoplanet, providing insights into its surface temperature and conditions that are essential for assessing habitability. Equally important, the near-infrared spectrograph, NIR-SPEC, allows astronomers to dissect the chemical makeup of an exoplanet's atmosphere by spreading out the starlight into a spectrum. This tool can detect water vapor, methane, and other organic compounds, offering clues about the potential for life as we understand it. With these advanced tools, the James Webb Space Telescope not only seeks to find exoplanets, but also to explore them in a depth that was previously unimaginable, bringing us closer than ever to understanding whether planets like Gliese 163c could truly be called Earth's cousins. The discovery. The James Webb Space Telescope made headlines with its discovery of Gliese 163c, an exoplanet that quickly captured the attention of astronomers and space enthusiasts alike. This significant find was announced after JWST's detailed analysis of the star system Gliese 163, located about 49 light-years away in the constellation Dorado. Using its advanced near-infrared spectrograph, JWST was able to detect the chemical signatures and thermal properties that suggest Gliese 163c might be within the star's habitable zone. Initial observations of Gliese 163c indicated several exciting possibilities. The planet's orbit places it at just the right distance from its star to potentially allow liquid water to exist on its surface, an essential criterion for Earth-like life. Moreover, the spectral data revealed hints of an atmosphere, which is another critical factor in considering the habitability of a planet. These early findings have laid the groundwork for more detailed studies, making Gliese 163c a prime candidate in the search for life beyond Earth. Criteria for habitability. When scientists search for potentially habitable planets like Gliese 163cc, they primarily focus on three critical criteria: atmosphere, temperature, and the presence of water. Each of these elements plays a pivotal role in supporting life as we understand it. Firstly, an atmosphere is crucial because it can regulate temperature, protect biological entities from cosmic and solar radiation, and provide essential gases that biological processes might require. For instance, an atmosphere rich in oxygen and nitrogen, like Earth's, can support aerobic life forms and water cycles. Secondly, the temperature of a planet is equally significant. It must be neither too hot nor too cold, enabling the existence of liquid water on the planet's surface. This Goldilocks zone is where temperatures are just right for liquid water to exist, not so cold that it freezes solid, and not so hot that it vaporizes away. Finally, the presence of water is often considered a key marker for life. Water is a solvent in which biochemical reactions occur, crucial for life on Earth. Thus, finding signs of water on Gliese 163c, whether in vapor form in the atmosphere or as liquid on the surface, would be a strong indicator that the planet could potentially be hospitable to life forms. These criteria guide astronomers as they use the JWST to observe exoplanets across the galaxy, searching for those rare worlds where conditions might just be right for life to emerge. Characteristics of Gliese 163c. Gliese 163c stands out in the cosmic lineup of exoplanets due to its intriguing characteristics. It orbits its host star, Gliese 163, at a distance that places it squarely within the star's habitable zone, which is the region where conditions might be just right for liquid water to exist on the planet's surface, a crucial factor for life as we understand it. The planet is approximately 6.9 times the mass of Earth, classifying it as a super-Earth. This size suggests a rocky composition with a more substantial atmosphere than our home planet, which could lead to a greenhouse effect, potentially warming the planet. The orbit of Gliese 163c is particularly fascinating. It completes a full revolution around its star in approximately 26 Earth days. Such a short orbital period indicates that the planet is much closer to its star than Earth is to the Sun. However, because Gliese 163 is a red dwarf and much cooler than our Sun, this proximity places Gliese 163c in the sweet spot for temperate conditions. Comparatively, Earth orbits the Sun every 365 days, which reflects our moderate distance from a much hotter star. The environmental conditions on Gliese 163c, inferred from its orbit and size, suggest a world that could host thick atmospheric layers capable of trapping heat. If water exists, its state, whether vapor, liquid, or ice, would heavily depend on atmospheric composition and surface pressure. In contrast, Earth's well-balanced atmosphere and magnetic field have created a stable environment where water can exist in all three states, supporting a diverse range of life forms. As we continue to study Gliese 163c, understanding these key differences and similarities will help scientists better assess the planet's potential for habitability and life. Technology behind the discovery. The James Webb Space Telescope leverages cutting-edge technology to unveil the secrets of distant worlds like Gliese 163c. Central to its success are several key instruments, each playing a vital role in this cosmic detective work. The near-infrared camera, NIRCam, is JWST's primary imager, capturing high-resolution images that bring distant stars and their orbiting planets into clearer view than ever before. This capability is crucial for spotting minute changes in brightness and position that hint at the presence of exoplanets. Additionally, the mid-infrared instrument, MIRI, provides new insights into the thermal characteristics of Gliese 163c, allowing scientists to analyze the heat signatures that differentiate it from its stellar background. MIRI's sensitivity to longer wavelengths is ideal for studying cooler objects in space, making it indispensable for assessing the habitability of colder, Earth-like planets. Another essential tool is the near-infrared spectrograph, NIRSpec, which can disperse the light from Gliese 163c into its component wavelengths. This spectroscopic analysis helps astronomers determine the planet's atmospheric composition by identifying specific molecular signatures, such as water vapor, methane, or carbon dioxide, key indicators of potential life-supporting environments. These instruments, working in concert, not only pinpoint the location and existence of planets like Gliese 163c, but also provide a detailed look at their atmospheres and possible conditions for life, ushering in a new era of exoplanet discovery. Data interpretation. Interpreting the data received from Gliese 163c is a meticulous process that begins with the initial reception of signals captured by the James Webb Space Telescope. These signals, primarily in the form of infrared light, are analyzed using a variety of computational models to determine the planet's atmospheric composition, surface temperature, and potential presence of water vapor, among other vital characteristics. The accuracy of these findings is paramount. To ensure reliability, astronomers employ several validation techniques. First, the data undergoes a peer review process, where multiple independent teams of scientists examine the findings. This collaboration helps to eliminate biases and verify the consistency of the results across different observational methods and software analyses. Additionally, the findings from Gliese 163c are cross-referenced with similar exoplanets data, providing a comparative baseline that bolsters the confidence in the interpretations. By integrating these methods, astronomers not only refine their understanding of Gliese 163c, but also enhance the broader scientific community's trust in these distant world observations. Hypothetical life forms. Gliese 163c, with its position firmly within the habitable zone of its star, ignites the imagination with possibilities of life. The conditions on this exoplanet, which closely mirror those of Earth in terms of temperature and potential water presence, lead us to consider what forms of life might thrive there. Picture, if you will, microbial life forms that have adapted to potentially extreme conditions, which could range from intense solar radiation to varying atmospheric compositions. Moreover, the possibility of more complex multicellular organisms cannot be dismissed. These organisms might possess unique adaptations to their environment, perhaps akin to extremophiles on Earth that thrive in the harshest conditions from deep sea vents to the frozen tundras. The presence of liquid water, a critical ingredient for life as we know it, could mean that aquatic life forms might dominate the biosphere of Gliese 163c. Imagine creatures that have evolved not only to survive but to flourish in the alien oceans or lakes of this distant world, developing novel biochemistries that challenge our very conception of life. Each hypothesis not only expands our understanding of biology, but also deepens the awe and mystery surrounding our universe's potential to harbor diverse life forms. What this discovery means. The discovery of Gliese 163c as a potentially habitable planet has profound implications, both scientifically and philosophically. From a scientific standpoint, this finding challenges and expands our understanding of habitable environments. It prompts a re-evaluation of how we study planetary atmospheres and climates, pushing us to develop more sophisticated models to predict and comprehend life-supporting conditions. Moreover, Gliese 163c offers a real-time laboratory for testing theories about planetary formation, evolution, and the potential for sustaining life. Philosophically, the discovery stirs profound questions about our place in the universe. The existence of another potentially habitable planet inherently suggests the possibility of life beyond Earth, which could fundamentally alter our understanding of life's uniqueness and rarity. It encourages us to reflect on our responsibilities as a species and the ethical considerations of exploring and potentially interacting with other life forms. The mere presence of such a planet invites us to ponder our solitude or kinship in the cosmos, potentially reshaping human consciousness and our philosophical outlook on life, existence, and the universe at large. Next steps in research. Building on the groundbreaking discovery of Gliese 163c, the scientific community is buzzing with plans for future missions aimed at delving deeper into this potentially habitable exoplanet. These ambitious missions are designed not only to confirm the preliminary findings about the planet's environment, but also to explore its atmosphere in much greater detail. One of the primary objectives is to analyze the atmospheric composition and look for signatures of gases like oxygen and methane that could indicate biological processes. Another focal point of upcoming missions will be to measure Gliese 163c's temperature gradients and seasonal variations, providing insights into its climate systems. This will help scientists understand whether conditions on the planet could support liquid water, a crucial ingredient for life as we know it. By deploying advanced spectroscopy and imaging techniques, these missions will capture high-resolution data, offering a clearer picture of the planet's surface and potential weather phenomena. Furthermore, astronomers hope to determine the planet's mass with greater precision. This is essential for understanding the planet's gravitational pull and its effect on potential atmospheres. Each piece of data brings us one step closer to answering the tantalizing question: could Gliese 163c be a second home for humanity, or perhaps already home to its own form of life? Through these efforts, we seek not just to discover but to profoundly understand what lies beyond our solar system. Learning from Gliese 163c. The discovery of Gliese 163c opens up a wealth of educational opportunities and has the potential to significantly boost public interest in astronomy and exoplanetary science. As educators integrate this new information into curriculums, students and the public alike can experience firsthand the thrilling evolution of our understanding of the universe. The concept of habitable exoplanets, such as Gliese 163c, provides a concrete example of how theoretical astrophysics impacts real-world science and stokes curiosity about life beyond Earth. This discovery also serves as an excellent tool for engaging the public in science. Media coverage and popular science content that discuss Gliese 163c can help demystify the process of scientific discovery, making the field of astronomy more accessible and appealing to a broader audience. It allows for interactive discussions, workshops, and potentially even citizen science projects where amateurs can contribute to ongoing research. The excitement generated by such findings can lead to increased funding and support for further space exploration, ensuring that the study of exoplanets remains a dynamic field at the forefront of scientific inquiry. Advanced scientific theories and models. The exploration of Gliese 163c has catalyzed the development of new scientific theories and models that aim to decode the complex environments of distant exoplanets. As astronomers analyze the data gathered by the James Webb Space Telescope, they are beginning to challenge and expand existing models of planetary habitability. For instance, the traditional model that categorizes a planet's potential for life based on its distance from the star is being nuanced with more complex variables such as atmospheric composition, magnetic fields, and orbital stability. These refined models consider how the unique characteristics of Gliese 163c, like its atmospheric chemistry and potential geothermal activity, could support life in ways that differ from Earth. The study of this exoplanet also allows scientists to test theories of planet formation and evolution in the context of different star systems. This not only enriches our understanding of how planetary systems develop, but also widens our search criteria for life-sustaining planets across the galaxy. By integrating observations from Gliese 163c into broader astrophysical models, we are on the brink of potentially discovering new types of habitable environments, fundamentally shifting our understanding of where life could exist in the universe. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
Professor Albert Einstein, who helped discover the atom bomb.
What do you put the chances of having found life?
So we have the observations, they're beaming in right now. So we're waiting for the data to come to us, and the analysis will start anytime.
Scientists have reached a significant milestone in the search for an interstellar home. In a surprising discovery made by the James Webb Space Telescope, they found a new planet with properties strikingly similar to Earth. Experts are now speculating that this planet could be the ideal home away from home and may already host extraterrestrial life. However, in the midst of this excitement, researchers in the scientific community stumbled upon yet another planet that could be even more suitable for humans than Earth. What are these newly discovered planets, and where were they found? What attributes lead experts to believe these planets are suitable for human life? What are the chances of finding intelligent extraterrestrial life on them? Stay tuned, as NASA has just uncovered a new planet better for life than Earth. With the growing threats of global warming, climate change, pandemics, and natural disasters, scientists believe Earth is slowly approaching a point of no return. It's only a matter of time before a catastrophic event could wipe out humanity. In light of this, researchers have been searching for a new planet in the cosmos that could serve as our next home, much like Earth. Initially, the search focused on planets within our solar system that could potentially support human life. This led the scientific community to send probes to various planets throughout the mid and late 1900s. Because Jupiter and Venus were too close to the Sun, the best options were narrowed down to Mars, Jupiter, Saturn, and Uranus. However, it became clear later that none of these planets would be suitable for human life. Jupiter's weather is extremely unstable, making it the most unpredictable planet in our solar system. Saturn's atmosphere is rich in hydrogen and experiences helium rain, while Uranus lacks oxygen, making it impossible for humans to breathe there. The most promising candidate so far is Mars. Although Mars is dry, arid, and prone to dust storms and radiation, experts like Elon Musk remain optimistic about making it habitable. Plans to establish a base on Mars are already in progress, but creating such a base would be challenging. It would require replicating Earth's conditions, including oxygen, gravity, water, temperature, and air pressure. The cost of such an endeavor would be astronomical, amounting to billions or trillions of dollars. It would be far easier to find a planet with the right conditions elsewhere in the universe rather than transforming Mars into a habitable one. As a result, scientists have expanded their search beyond our solar system, exploring distant regions of space to identify a planet like Earth, or perhaps an even better one. To streamline the search for a suitable replacement, scientists developed the Earth Similarity Index. This index evaluates planets using factors like temperature and atmospheric pressure to determine how closely they resemble Earth and whether they could support life. The scale runs from 0.0 to 1, with higher numbers indicating a closer match to Earth. For instance, a planet with a similarity index of 0.9 would be nearly identical to our planet. With significant technological advancements, scientists have been able to explore the deepest regions of the cosmos, revealing promising candidates for human habitable planets. Among these are exoplanets and moons with striking similarities to Earth. One notable discovery from 2019 is the planet Teegarden B, one of the closest potentially habitable planets, situated about 12.4 light-years away. Its mass is 1.05 times that of Earth, making it almost identical in size. Teegarden B orbits an M-type star, Teegarden, a red dwarf. These stars are relatively cool, with surface temperatures below 3,600 Kelvin. The Teegarden star in particular is much smaller than our Sun, with a temperature around 2,700 Kelvin. Despite its low heat, the red dwarf provides enough warmth for its planets, Teegarden B and Teegarden C. Teegarden B orbits its star at a distance of 0.252 astronomical units, while Teegarden C, the other planet in the system, orbits at 0.04 astronomical units, completing its orbit in about 11 days. Both planets share characteristics with Earth, notably being located in the habitable zone of their star. This zone refers to the distance at which liquid water could exist on the planet's surface. If too far, the water freezes, too close, and it evaporates. For example, Neptune has frozen water due to its distance from the Sun, while Venus lacks water altogether, even in its atmosphere. Earth, however, is at the perfect distance for life. The discovery of Teegarden B and C indicates Earth isn't unique in this regard. Teegarden B stands out with a promising score of 0.95 on the Earth Similarity Index, ESI, which means it's nearly 100% similar to Earth. However, uncertainties remain regarding air pressure and temperature, with estimates ranging from 0 to 50 G. If its atmosphere is Earth-like, its surface temperature could be around 28 G. Teegarden C, being farther from the star, is more likely to be too cold. Experts believe it has only a 3% chance of a warm surface temperature and suspect its atmosphere may resemble Mars, with temperatures near 47 degrees Celsius. Its ESI score is 0.68. Currently, researchers don't know much about the atmospheres of Teegarden B and C, as both are tidally locked to their star. Scientists estimate their atmospheres could be 13 to 17 times denser than Earth's. There's plenty of speculation about these two planets, with some believing they could be future homes for humanity if Earth faces a catastrophic event. On the other hand, many scientists are also exploring the possibility of extraterrestrial life on these planets. For centuries, we've questioned whether we are alone in the universe. This mystery has driven both astronomy and cosmology. Despite extensive research, no alien civilizations have been found. No stars or planets have yet exhibited the ideal conditions to support extraterrestrial life. The planets that are thought to be viable for life are those with the right temperatures, atmospheres, and those situated in the habitable zones of their stars where water can exist. Water is essential for any living organism. As the saying goes, water is life. Scientists have long recognized that wherever water is present in the universe, life can likely be found. This is why planets such as T-Garden B attract significant attention when researchers search for planets that might harbor alien life. But T-Garden B isn't the only planet of interest. Other planets are also considered strong candidates for supporting extraterrestrial life. One planetary system in particular is seen as even more promising than T-Garden, the TOI 700 system. Located in the constellation Dorado, this star system contains 4 planets, with 2 of them residing in the star's habitable zone. The standout planets are TOI 700d and TOI 700e. Both planets have masses comparable to Earth's and feature rocky surfaces. TOI 700e is approximately 95% of Earth's size, with an orbital period of 28 days, while TOI 700d is about 105% the size of Earth, completing its orbit in 37 days. What makes the TOI 700 system particularly intriguing is its age, around 1.5 billion years. That puts it just a few billion years younger than our solar system, which is about 4.6 billion years old. According to cosmic timelines, 1.5 billion years is more than enough time for life to develop and evolve on a planet. Some experts believe that TOI 700e and 700d could host rich biospheres. If these planets have atmospheres warmer than Earth's, they could not only be suitable for us but also for alien species with similar biological traits. If we were to find life on these planets, it would likely resemble the life forms found on Earth, as we tend to look for biological traits that are familiar to us. However, this is all speculative at this stage. Until we can closely study these planets' atmospheres, surfaces, and environmental conditions, we may never truly know what kinds of life forms they might host, if any at all. It's possible that planets scattered across the cosmos could house similar life forms, shaped by the same fundamental principles of biology. But there is still so much about the vast universe that remains beyond our comprehension. The potential for completely different evolutionary paths driven by conditions that are unlike anything we've encountered adds an even greater layer of mystery. For instance, the principles of evolution could function very differently on other planets compared to Earth. Evolution, like gravity, is thought to be a universal process. The concept of evolutionary convergence suggests that unrelated species can develop similar traits when they face comparable environmental challenges. Consider species like crocodiles, which have evolved to swim and breathe underwater. If similar creatures existed on water-dominated planets, they too would evolve to adapt to underwater environments. However, their evolutionary paths might differ. While some aquatic animals have developed gills to extract oxygen from water, others have not, relying on different adaptations for survival. Similarly, birds, insects, mammals, and other airborne creatures have evolved various methods to take to the skies, each suited to their specific needs. Birds, for example, soar by flapping their wings, generating the lift they need to remain airborne, while mammals like flying squirrels use a different approach, gliding gracefully by stretching out their loose skin to create a makeshift parachute. Every creature has its own unique way of conquering the air, whether it's through flapping, gliding, or hovering. It's highly likely that this incredible diversity of flight and movement is also unfolding on other planets with biolife, scattered throughout the universe, where alien species have evolved their own specialized adaptations to navigate their environments. There is also a possibility that some of these planets could evolve complex biolife forms. These advanced life forms would be entirely different from anything we've encountered on Earth. Environmental conditions like temperature, atmospheric pressure, and water availability could heavily influence how these organisms evolve, driving them to adapt in ways that seem strange to us. Scientists are keeping their minds open to the idea of discovering biolife that defies our current understanding. On Earth, some organisms exhibit bizarre traits and have adapted to survive in extreme environments, from the deepest parts of the ocean to the hottest volcanic vents. These extraordinary life forms, known as extremophiles, can thrive in conditions that would be lethal to most other species, such as extreme temperatures, high radiation, or toxic chemicals. Their unique adaptations make them valuable models for the kinds of alien organisms that might exist on other distant planets with similarly harsh or unusual conditions. So far, most searches for extraterrestrial life have centered around planets with close similarities to Earth, focusing on finding life as we know it. However, studying extremophiles helps us imagine how life could evolve in radically different environments, expanding our understanding of where life might exist in the cosmos. But what if we change our perspective? Instead of limiting our search to life as we know it, we could widen the scope and explore the possibility of life that's fundamentally different. Life as we don't know it. After all, given how little we truly understand about the vast complexities of the universe, it's not unreasonable to consider that extreme bio-life forms could be thriving on planets we've dismissed as uninhabitable. These planets may endure intense radiation, have an excess of particular elements, experience extreme temperatures far beyond what we consider survivable, or face severe, relentless weather. Yet in these harsh and hostile environments, there may exist life forms perfectly adapted to not just survive, but to flourish in conditions that would be unthinkable for organisms like those found on Earth. A few years ago, astronomers identified a new type of planets known as hen exoplanets, which may have the potential to support life. These planets are significantly larger, hotter, and covered with oceans, providing them with a wider habitable zone compared to Earth. Some of these exoplanets experience atmospheric pressures as high as 200 XU. They meet important criteria, including having substantial amounts of water. However, due to the extreme conditions, any biolife that might exist on these planets would be very different from the life forms we are familiar with. One fascinating example from this category is planet K2-18b. Discovered in 2015, it is one of the numerous planets found by NASA's Kepler Space Telescope. The Kepler Space Telescope, launched by NASA in 2009, was designed to search for Earth-sized planets orbiting stars within nearby regions of the cosmos. Named after the astronomer Johannes Kepler, the telescope was placed in a heliocentric orbit, meaning it orbits the Sun while gradually drifting farther away from Earth as it continues scanning the universe. Thanks to Kepler, scientists determined that approximately 25 to 50% of stars visible in the night sky likely have small rocky planets, much like Earth. Kepler's findings included multiple planets located within the habitable zones of their parent stars, and K2-18b is one such planet. Situated roughly 124 light-years from Earth in the constellation Leo, this planet is reminiscent of a mini-Neptune orbiting a dim red dwarf star. Researchers suggest that planets like K2-18b could harbor life due to their potential to contain biomarker molecules. These molecules, often remnants of organic processes, can be detected in soil and water samples by space rovers or in the atmosphere through telescopes and orbiters. Common biomarker molecules include methyl chloride and dimethyl sulfite. In some cases, planets may have elements such as oxygen, methane, or hydrogen as predominant components. Earth's life forms are carbon-based, as carbon is the dominant element on our planet. If a planet lacks carbon, life forms there could have a radically different structure. For example, life forms based on hydrogen would be unrecognizable to us, especially when viewed through the lens of our own biochemistry. Planets like K2-18b are rare because they share the same key biomarker as Earth, carbon. The James Webb Space Telescope, or JWST, has revealed the presence of carbon molecules alongside traces of methane and carbon dioxide on this planet. This discovery positions K2-18b at the forefront of Earth-like planets with the potential to support biolife. Kepler K2-188b isn't the only noteworthy planet. Another intriguing but debated candidate is TRAPPIST-1b, discovered in 2016. This planet is about 1.5 times larger than Earth, and data indicates it may be capable of supporting life. According to NASA astrophysicist Thomas Green, TRAPPIST-1b has a thick atmosphere that helps protect its surface from excessive heat or radiation. However, the planet orbits much closer to its star than Earth does to the Sun, receiving far more light. The JWST has found that TRAPPIST-1b's daytime temperatures exceed 200 degrees, making it lethal for humans, yet possibly ideal for other types of life forms. With advanced space telescopes like the James Webb, we can now explore the atmospheres of distant planets in greater detail than ever before. Thanks to the recent incredible discoveries by the JWST, it seems clear that many more astonishing findings are on the horizon. In fact, some scientists believe that there could be planets in the universe with even more favorable conditions for life than Earth. These planets are known as superhabitable worlds. Imagine a planet that is larger, safer, and more hospitable than Earth, free from the challenges we currently face. Though still a theoretical concept, superhabitable worlds would likely be older, bigger, warmer, and perhaps even more humid than Earth. Many researchers speculate that these planets might orbit stars much older than our Sun, with significantly longer lifespans. For example, while our Sun has an expected lifespan of about 10 billion years, it took nearly 4 billion years for life to develop on Earth. Some stars, however, can last much longer than 10 billion years, allowing for a more prolonged and intricate evolutionary process on their orbiting planets. But how can we locate these ideal planets? According to many experts, the best approach is to search for planets orbiting orange stars that are cooler and less bright than our Sun. Such stars would need lifespans between 20 and 70 billion years. It is believed that life on planets around these stars could evolve fully, reaching a point where the planet's geological features and life forms are at their most developed. These superhabitable worlds would likely offer many advantages over Earth, such as more landmass, heat sources that last longer, better protection from radiation, and ideal gravitational conditions. For a planet to be truly superhabitable, it should also have an average surface temperature about 500 degrees Celsius warmer or cooler than Earth's, promoting greater biodiversity. Although no such planet has been found yet, scientists remain optimistic. The scientific community at least has a clearer idea of what they are looking for and where to search. Still, there are skeptics who argue that no planet could be better suited for human life than Earth. If such a planet existed, they claim, it would have already been discovered. However, it's important to note that the technology we have now wasn't available in the past, which might explain why we haven't found one yet. Perhaps with future advancements, our telescopes will one day reveal the perfect planet for humanity. For now, the search for a new home continues. Thanks for watching this episode. Be sure to click the video on your screen for more fascinating insights into space. Apollo 11's mission to the Moon on July 20th, 1969 was one of the most significant events in human history.
To achieving the goal, before this decade is out, of landing a man on the Moon and returning him safely to the Earth.
Astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface.
It's one small step for man, one giant leap for mankind.
While Michael Collins orbited above in the command module. This achievement symbolized human ingenuity and determination. However, Buzz Aldrin has long intrigued the public with his comments about the Moon. Over the years, he has hinted that the Moon may not be exactly what we think, sparking curiosity and speculation about its mysteries. Aldrin's views on the Moon often venture into the unusual. The second man to walk on the lunar surface, Aldrin has openly discussed his experiences during the mission. While most see the Moon as a barren, lifeless satellite, Aldrin has implied there's more to it. His reflections range from personal experiences to broader thoughts on what the Moon might represent for humanity, challenging the conventional view of the Moon as a cold, rocky body and suggesting that its mysteries are far from fully uncovered. During the Apollo 11 mission, Aldrin and Armstrong conducted experiments and collected samples to bring back to Earth. However, Aldrin has hinted in interviews that their time on the Moon may have revealed phenomena not fully disclosed to the public. Though his comments are often vague, they suggest the Moon could harbor unknown phenomena, leaving room for speculation and imagination about what was truly observed during the first lunar landing. Aldrin often emphasizes the sense of awe and mystery he felt on the Moon, describing it as an otherworldly place. His experience seemed to go beyond the typical overview effect astronauts describe, implying the Moon may hold deeper meaning or secrets. His reflections evoke a mystical quality to the lunar surface, defying simple scientific explanation. Aldrin's comments also raise broader questions about humanity's place in the universe. For millennia, the Moon has inspired mythologies, religious beliefs, and scientific inquiry. Aldrin suggests that the Moon's significance might extend beyond its role as Earth's satellite, hinting at mysteries yet to be understood. potentially reshaping our understanding of the cosmos and our role in it. This resonates with the idea that the moon symbolizes the unknown, a reminder of the mysteries still beyond human comprehension. One intriguing aspect of Aldrin's perspective on the moon is what might lie beneath its surface. While the Apollo missions, including Apollo 11, provided valuable data, much of the moon's interior remains a mystery. Some scientists believe the moon could reveal clues about the solar system's formation, and Aldrin's musings suggest it may hold more than geological secrets, perhaps hidden structures, ancient artifacts, or other unknown phenomena. Aldrin has also fueled speculation about extraterrestrial activity. He once mentioned seeing an unusual object during the Apollo 11 mission, later clarifying it was likely part of the rocket, but the incident added to the mission's mystique. The moon's unique position in Earth's orbit, being unusually large and nearly perfectly circular, has led some to theorize it might be an artificial object created by an advanced civilization. While Aldrin hasn't endorsed this idea, his open-mindedness toward the moon's mysteries leaves room for speculation. Aldrin sees the moon as a crucial stepping stone for future space exploration. He has long advocated for continued lunar exploration and using the moon as a base for missions to Mars and beyond. Aldrin believes humanity's future lies in space, and establishing a permanent presence on the moon is essential, not just for scientific reasons, but also as preparation for further space travel. To him, the moon is both a mystery to solve and a gateway to the broader cosmos. Aldrin's respect for the unknown drives his curiosity about the moon, believing much remains undiscovered. He encourages humanity to keep exploring and questioning what we know, aligning with the spirit of pushing the boundaries of space exploration. For him, the moon is the frontier where humanity might confront the unknown and uncover extraordinary discoveries. Recently, Aldrin has stressed the need for renewed space exploration, especially as Earth faces global challenges. He believes the moon could help address these issues by serving as a platform for scientific research, resource extraction, and even habitation. His reflections on the moon's mysteries suggest that some of the answers to pressing human challenges may lie not on Earth, but on the moon and beyond. The implications of Aldrin's views on the moon are profound. If the moon is more than just a barren rock, as Aldrin implies, it could reshape our understanding of the universe and our place in it. The possibility that the moon holds hidden secrets, whether ancient artifacts, unknown geological formations, or signs of extraterrestrial activity, challenges the conventional narrative of space exploration and raises questions about what we truly know about our closest celestial neighbor. Aldrin's reflections encourage a re-evaluation of humanity's relationship with space. While space exploration has traditionally been driven by scientific curiosity, technology, and geopolitical competition, Aldrin suggests deeper philosophical reasons to continue exploring. The moon, in his view, symbolizes the unknown and reminds us that mysteries in the universe remain to be uncovered. This perspective calls for a more holistic approach to space exploration, considering not just the scientific and technological aspects, but also the broader implications for humanity's future. As NASA's Artemis program aims to establish a sustainable presence on the moon, Aldrin's reflections gain more significance. This new era of lunar exploration could provide answers to some of Aldrin's questions and reveal new mysteries. The possibility that the moon holds more than we previously thought adds excitement and intrigue to upcoming missions. It also reminds us that despite technological advancements in space exploration, profound questions about the universe remain unanswered. Aldrin's fascination with the moon stems from his first-hand experience of walking on its surface, which significantly shaped his worldview and led him to question established understandings of our natural satellite. While most focus on the triumph of Apollo 11, Aldrin's reflections emphasize the strangeness and mystery of the experience. His perspective suggests the moon may hold more significance than we realize, challenging our knowledge and inviting deeper exploration. Aldrin's insights indicate the moon may not be just a barren, lifeless rock, but something much more enigmatic. Aldrin's comments often suggest that the moon could be a key to understanding deeper cosmic mysteries, possibly linked to our understanding of space, time, and the origins of life. One major question raised by Aldrin's reflections is the moon's origin. While the prevailing theory is that the moon formed from debris after a giant impact between Earth and another planetary body, some aspects of its composition and behavior remain unexplained. For example, certain elements on the moon's surface do not fit neatly into this hypothesis, leading Aldrin to speculate that unknown processes may have influenced its formation. Aldrin has also expressed intrigue over the moon's gravitational relationship with Earth. While its role in stabilizing Earth's axial tilt in controlling tides is well known, Aldrin has suggested that this relationship might be more complex than we currently understand. The moon's orbit and its influence on Earth raise questions about whether an unknown force may govern these interactions, inviting further exploration of how celestial bodies affect one another in ways that might still be unexplored. Aldrin's interest in the moon is strongly connected to his curiosity about extraterrestrial life. While he has never claimed to have seen aliens or found direct evidence of their existence, his open-mindedness about space's mysteries often leads to speculation. The moon, being Earth's closest celestial body, is seen as a potential starting point for discovering life beyond our planet. Aldrin has suggested that if extraterrestrial life exists, it might have left traces on the moon, such as artifacts or subtle signs not easily detected. This makes the moon a significant target for future exploration. Aldrin's reflections also show his willingness to consider unconventional ideas, including the possibility that advanced civilizations visited the moon long before humans. Though speculative and lacking evidence, his open-mindedness encourages exploration of these ideas to deepen our understanding of the moon's history. Aldrin has speculated that the moon could serve as a hub for future human expansion into space. He has long advocated for permanent lunar bases to support missions to Mars and beyond, making the moon a critical stepping stone for humanity's future in space. His reflections weave together two ideas. The moon holds unexplored mysteries, and it plays a vital role in humanity's continued exploration of the cosmos. Aldrin's Apollo 11 experience instilled in him a sense of wonder and humility, seeing the moon as a symbol of the unknown, urging humanity to push the boundaries of knowledge and capabilities. A recurring theme in Aldrin's reflections is the potential for life beyond Earth. While the moon is unlikely to harbor life, its proximity to Earth and role in space exploration make it a key location for studying conditions that could support life elsewhere. Aldrin has suggested that the moon could be a laboratory for experiments to help understand the origins of life on Earth and other planets. Studying the moon's geology and solar interactions could offer clues about life's emergence in the universe. Aldrin is also interested in the moon as a platform for studying Earth and the cosmos. Its lack of atmosphere and stable position make it ideal for astronomical observations. He has advocated for building lunar observatories to study the universe in ways not possible from Earth, highlighting the moon's potential to unlock the mysteries of the universe. The idea of the moon serving as a base for human activity raises important questions about resource utilization. Aldrin has often discussed the potential for mining the moon's resources, particularly helium-3, a rare isotope that could be used for future energy production. Although this presents significant technical and ethical challenges, the possibility of supporting human exploration and development in space has intrigued Aldrin for decades. He emphasizes the need for careful planning and international cooperation to use these resources responsibly and sustainably. Aldrin is also optimistic about humanity's future in space. He believes that while space exploration poses challenges, they are not insurmountable. His Apollo 11 experience instilled in him confidence in human ingenuity and perseverance. For Aldrin, the moon is both a challenge and an opportunity, a place where humanity can test its limits and move forward into new frontiers. His reflections often emphasize that the moon, while mysterious and sometimes daunting, symbolizes hope and humanity's potential for great achievements. Beyond its scientific and exploratory significance, Aldrin has suggested the moon could help foster global unity. The Apollo 11 mission was a triumph for all humanity, not just the United States. Aldrin frequently speaks of the awe and wonder people worldwide experience watching humans set foot on another world. He believes future lunar missions could unite nations in pursuit of common goals, making the moon not just a scientific frontier, but a place where humanity collaborates toward a shared future. Aldrin's reflections emphasize the importance of preserving the moon's environment. Though a strong advocate for human exploration and development, he stresses the need for careful stewardship of the moon's fragile ecosystem. Its barren surface holds vital clues about the solar system's history, and Aldrin warns against damaging or disrupting this natural environment. His views highlight the balance between exploration and preservation, a critical theme as humanity's presence in space grows. Aldrin also believes the moon could serve as a training ground for future spacefarers. Its harsh conditions, low gravity, lack of atmosphere, and extreme temperatures provide an ideal environment for astronauts to develop skills and technologies for missions to Mars and beyond. He advocates for lunar training facilities, aligning with his vision of using the moon as a stepping stone for further exploration. Additionally, Aldrin sees potential in space tourism and commercial ventures on the moon. With companies like SpaceX and Blue Origin advancing space travel, he envisions partnerships between governments and private industry, making the moon a destination for tourists as well as scientific exploration. This idea builds on the growing trend of space commercialization, where private companies are increasingly taking on roles traditionally held by government space agencies. Aldrin envisions a future where private enterprise plays a key role in making the moon accessible, creating new opportunities for economic development and human experience. Beyond tourism, Aldrin sees the moon as a platform for advancing space-based manufacturing and technology development. The moon's low gravity and lack of atmosphere offer unique conditions for testing technologies such as space habitats, energy production, and resource extraction. He has emphasized the moon's potential as a testing ground for technologies critical to future Mars missions, including advancements in life support systems, radiation shielding, and habitat construction, all of which could be refined on the moon before being used for longer missions to Mars or beyond. Aldrin's interest in technology focuses on the long-term sustainability of human activities on the moon, particularly through renewable energy sources like solar power. The moon's lack of atmosphere and extended sunlight make it ideal for generating solar energy, which could power lunar bases and support human habitation. Aldrin has suggested that lunar solar power could also meet Earth's energy needs, transmitting energy back to Earth via microwave or laser beams. This concept, though early in development, could help address global energy demands and reduce reliance on fossil fuels. He also believes the moon's resources, such as helium-3 for fusion energy, could play a crucial role in solving challenges like climate change and resource depletion. While fusion energy technology is still being developed, Aldrin sees the moon playing a key role in providing clean, sustainable energy for future generations. His reflections also emphasize the importance of international cooperation in the exploration and utilization of lunar resources, stressing that the moon belongs to all humanity. Aldrin advocates for international frameworks to ensure responsible use of space resources, similar to the treaties governing Antarctica, to prevent conflicts and ensure equitable sharing of benefits. He frequently highlights the idea of space as a global commons and views space exploration as a shared human endeavor that transcends borders and political divisions. This perspective is especially relevant as more countries and private entities join space exploration. Aldrin advocates for international cooperation, believing that the challenges of exploring and using the moon and other celestial bodies are too vast for any one nation or organization to handle alone. He envisions countries working together, sharing knowledge, resources, and expertise to benefit all of humanity. Aldrin also emphasizes long-term thinking over short-term, politically driven decisions. For him, the moon offers a chance to lay a foundation for future exploration that will benefit both current and future generations of astronauts and spacefarers. He believes today's decisions on how we explore and use the moon will significantly impact humanity's future in space. Therefore, he supports a long-term, strategic approach prioritizing sustainability, cooperation, and responsible resource use. Aldrin's focus on long-term thinking ties closely to his belief in inspiring the next generation of scientists, engineers, and explorers. Throughout his career, Aldrin has passionately advocated for STEM education, often emphasizing the need to inspire young people to pursue careers in science and space exploration. He sees the moon, with its mysteries and potential, as a unique opportunity to capture the imagination of future generations. By pushing the boundaries of our knowledge and continuing to explore the moon, Aldrin hopes to inspire young people to dream big and contribute to advancing human knowledge and exploration. Aldrin's reflections on the moon also carry a spiritual dimension, often overlooked in discussions of space exploration. Though a man of science, Aldrin has acknowledged the profound awe that comes with seeing the universe from space. He often describes walking on the moon as both a scientific and deeply spiritual experience. For Aldrin, the moon symbolizes our connection to something larger, a reminder of the vastness of the universe and our small yet significant place within it. This sense of wonder is central to his reflections, underscoring that exploring celestial bodies isn't just about data or resources, but expanding our understanding of the universe and ourselves. This spiritual aspect also informs Aldrin's views on the ethical responsibilities of space exploration. He emphasizes the need for humility and respect, recognizing that we are venturing into parts of the cosmos we don't yet fully understand. Aldrin believes that as we explore the moon and beyond, we must act as stewards of the universe, avoiding harm to the environments we encounter or exploitation of resources that could negatively impact future generations. This view reflects a deep respect for the unknown and the potential for space exploration to reshape our understanding of the universe and ourselves. Aldrin's thoughts on the moon intersect with his broader interest in human evolution and survival. He has spoken frequently about humanity's need to expand beyond Earth to ensure long-term survival. For Aldrin, the moon is the first step, a place to develop the technologies and skills needed to thrive in space. The challenges of space exploration, he believes, will push humanity to evolve, both technologically and in understanding what it means to be human. Thus, the moon is not just a destination, but a catalyst for human evolution, testing our limits and preparing us for the next phase of cosmic exploration. Aldrin's vision of the moon as a stepping stone is also tied to his interest in space colonization. He advocates for permanent human settlements on the moon as a way to ensure humanity's continued presence in space. These settlements, he believes, could serve as bases for future missions to Mars and beyond, providing the infrastructure necessary for long-duration space travel. Aldrin's vision of lunar colonization isn't just about survival, though. It's also about expanding human civilization into new frontiers. He envisions a future where humans live and work on the moon, creating societies that reflect the diversity and creativity of humanity. In addition to colonization, Aldrin believes the moon could play a key role in scientific discovery. He frequently speaks of its potential as a base for studying the cosmos, conducting experiments, and pushing the limits of human knowledge. The moon's unique environment, lacking an atmosphere and close to Earth, makes it ideal for scientific research, particularly in astronomy, geology, and biology. Aldrin envisions the moon becoming a hub for global scientific discovery, drawing researchers from around the world to unlock the universe's secrets. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what surprises you expect from this reveal. We want to hear from you. Thanks for watching, and see you next time.
5, 4, 3, 2, 1, 0. All engine running.
I am Buzz Aldrin.
One small step for man, one giant leap for mankind.
And I was the lunar module pilot on Apollo 11.
Stage 5 clear. Roger.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Buzz Aldrin, one of the few men to have walked on the moon, possesses unique insights about it thanks to his experience as a lunar astronaut. Later in life, he shared intriguing observations, hinting at mysterious entities or phenomena close enough to be observed on the moon. Does Aldrin's observations challenge conventional knowledge about the moon?
I thought it was a good idea in front of the TV to bounce around and to demonstrate how easy a guy could move around, or a gal could move around on the moon.
Is the moon not what we think it is? Let's learn more about this person. Buzz Aldrin, an astronaut renowned for his academic prowess, including a PhD from MIT, played an instrumental role in the historic Apollo 11 mission as the lunar module pilot. As the pilot of the lunar module, Aldrin had a massive job. He had to land on the moon and then make sure they could get back to Earth safely. This guy wasn't just very intelligent. He was also a top fighter pilot in the Korean War. His mix of brainpower and flying skills was key to the mission's success. But there's more. We're also looking at how Aldrin kept his cool under pressure. Imagine this, you're descending to the moon and you're hit with computer alarms, unknown boulders on the surface, and your fuel's running low. Sounds scary, right? Well, Aldrin, alongside Neil Armstrong, handled it like a pro. His ability to stay calm and make quick, smart decisions was crucial, especially during those tense moments. Thanks to him, the Eagle landed safely on the moon. Stay tuned as we explore the amazing journey of Buzz Aldrin on Apollo 11. The historic moon landing. Guess what? Buzz Aldrin was the second guy to walk on the moon right after Neil Armstrong. When he stepped onto the moon, he didn't just make history, he became a part of it. But walking on the moon was just one part of his mission. Aldrin was super busy up there, setting up all sorts of science experiments. These weren't just any experiments. They were designed to help us learn everything about the moon, like what it's made of and what its surface is like. Thanks to him, we know a lot more about the moon now. Aldrin also did something really important. He planted the American flag there. This wasn't just about being patriotic. It was a big moment showing what humans can achieve when we aim for the stars. And there's this special thing he did that not many people know about. While he was on the moon, Aldrin took some time for a personal spiritual moment. He actually took communion. It's a reminder that behind all the science and exploration, there's a human touch. Let's talk about how Aldrin described the moon. He called it magnificent desolation. What a way to describe it. It's like he was saying the moon is incredibly beautiful, but also really empty and quiet. It must have been such an unreal experience to stand there in this huge, silent place, so far from Earth. Space sickness experience. Let's dive into something that is about Buzz Aldrin that is not talked about much. His experience with space sickness during the Apollo 11 mission. You know, being an astronaut is not just about the cool stuff like floating in zero gravity or walking on the moon. There are some tough challenges too, and space sickness is definitely one of them. You can compare it with seasickness if you have ever had it before. Now, when Aldrin was up there in space, he actually got really sick. But here's the thing. Back then, nobody really talked about it. It wasn't until later, in his autobiography and some interviews, that Aldrin opened up about this experience. This was a big deal because it showed a side of astronauts we don't often see, their human, vulnerable side. Space sickness, or what they call motion sickness in space, can be pretty rough. Imagine feeling dizzy, nauseous, and just all around terrible while you're trying to do your job millions of miles away from Earth. It's not fun. Aldrin dealing with this while on such an important mission just shows how tough and resilient astronauts have to be. But why is this important? Well, it reminds us that astronauts are people too. They face challenges and have to overcome them just like the rest of us. Aldrin sharing his story of space sickness helps us understand and appreciate the real human side of space exploration. It's not always smooth sailing or smooth flying in this case. Theories on extraterrestrial life and moon's far side. Now let's talk about something that's really out of this world. Buzz Aldrin has dropped some hints that have got everyone talking. He suggested that there might be hidden structures or even bases on the far side of the moon. This could mean something huge, like ancient civilizations or extraterrestrial activity. This idea isn't just some sci-fi fantasy. It's coming from a man who's actually walked on the moon. So when Aldrin talks about these possibilities, people listen. His comments have sparked a ton of interest and loads of speculation, not just among space enthusiasts, but even in the scientific community. Now think about it. The far side of the moon is this mysterious place that we've never seen from Earth. So when someone like Aldrin hints at something hidden over there, it's no wonder everyone's imagination goes into hyperdrive. Could there be structures we've never seen before? Signs of ancient moon visitors? Maybe even evidence of aliens? These ideas have sent people rushing to look at lunar images and data, searching for any clues that might support Aldrin's suggestions. But here's the thing. While some people claim they found evidence of weird structures or unnatural formations on the moon, a lot of it could be our brains playing tricks on us, seeing patterns that aren't really there. That said, the fact that a seasoned astronaut like Aldrin even entertains these ideas adds a serious dose of intrigue to the whole discussion. Observation of a mysterious object in space. During the historic Apollo 11 mission, Aldrin reported something extraordinary. He observed an object in space that he couldn't identify. This wasn't just a piece of their spacecraft or some random space junk. It was something different, something that even a seasoned astronaut like Aldrin couldn't recognize. Now, imagine this. You're thousands of miles away from Earth in the vast emptiness of space, and you see something mysterious floating out there. That's exactly what happened to Aldrin. This wasn't a quick glimpse either. He saw an object that seemed to move in a controlled way, not just tumbling through space like debris. This sighting was unusual enough to catch the attention of the entire crew. This sighting sparked a lot of conversations and theories, especially about the possibility of extraterrestrial life. It's one of those incidents that make you wonder what's really out there. Was it an optical illusion, a reflection, or something more? Some space enthusiasts even dared to ask if it could be evidence of intelligent life, taking an interest in humanity's first journey to the moon. Aldrin has been open about this experience, discussing it in interviews and being transparent about what he saw and felt. He didn't jump to any wild conclusions, but he also didn't dismiss what he saw as nothing. This account from Apollo 11 adds a layer of mystery and excitement to the mission's story. Belief in extraterrestrial life. Aldrin has some other fascinating thoughts about life beyond Earth. Think about it. The universe is incredibly huge, with billions of galaxies, each filled with billions of stars. Around those stars orbit countless planets. Aldrin thinks that in all that immense space, it's almost more unlikely that Earth is the only place with life. He's not just dreaming big. He's basing his ideas on the probabilities given the size of the cosmos. But Aldrin doesn't stop at just believing there's life out there. He's a big advocate for continuing to explore space, to push further into the unknown. Why? Because he thinks that by exploring, we might actually find other life forms. Imagine the breakthroughs and the leaps in understanding we could achieve if we encountered life beyond Earth. Aldrin's perspective is really a call to action for humanity. He's urging us to keep exploring space, not just to satisfy our curiosity, but also to connect with potential life out there. This isn't just about launching rockets and satellites. It's about a deeper understanding of our place in the universe. Life on the moon, possibilities and challenges. Now, when we think of the moon, we usually picture this barren, desolate landscape with extreme conditions. It's a place with no atmosphere, extreme temperature swings, and bombarded by cosmic rays and solar winds. Not exactly the kind of spot you'd think life would call home, right? But there's more to this story. It's this wild idea that life can actually hitch a ride across the cosmos, potentially even reaching the moon. This could happen through asteroids, comets, or even interstellar dust. Imagine tiny life forms or organic materials getting a lift from Earth or other planets and ending up on the moon. But that's not the only way life could make it to the moon. Human activity could also play a part. We've been sending spacecraft and landers to the moon since the 1950s. Now, what if some of these missions accidentally carried microscopic stowaways? It's entirely possible. In 2019, an Israeli spacecraft called Bereshit crashed on the moon. But it wasn't alone. It had a payload that included thousands of tardigrades. If you don't know what tardigrades are, they're these tiny, tough animals that can survive extreme conditions. We're talking about surviving in space. So there's a chance these little guys could be living it up on the moon right now. Now, we're not saying there's a thriving ecosystem up there. If there's any life on the moon, it's probably super simple, like bacteria or fungi, and it would have to be in very isolated spots, like inside rocks or in ice at the poles. While it's unlikely that the moon has its own native life forms, the idea that life could hitch a ride that isn't so far-fetched. It's these kinds of possibilities that make space exploration so exciting. We're constantly learning and re-evaluating our understanding of life in the cosmos. What do you think? Do you believe in Buzz Aldrin's observations? Could it possibly be any life beyond our planet, or even on our neighbor the moon? Let us know your thoughts in the comments below. We hope you found these facts intriguing. If you heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.